பருவம் பருவம் மௌனம் புரிகின்ற தருணம் தருணம் கண்கள் கலக்கின்ற நிமிடம் நிமிடம் கால்கள் தொடர்கின்ற நடனம் நடனம் சுத்தி சுத்தி நின்ன மயக்கம் கனவு நகரமோ மெதக்கும் மெதக்கும் காதல் வந்ததும் குதிக்கும் குதிக்கும் சிறகால் வாரத்தை இடிக்கும் இடிக்கும்
கே மாறி முத்துங்க. வாட் யூ நேம்? வேற மாதிரி பேசணும். என்னங்க நீங்க ரொம்ப அழகா இருக்கீங்க.
தேங்க்ஸ்.
ஒரு சின்ன போய் சொன்னதுக்கு இவ்வளோ வெக்கப்படுறீங்க? ராத்திரி பகலாத்தா நெஞ்சில ராட்டிடம் சுத்துதடி பூட்டின வீட்டுலடா புதுசா பட்டா பூச்சி பறக்குதடா கருச்சாங்குருக்கு மயக்கம் மயக்கம் கனவு நகரமோ மெதக்கும் மெதக்கும் காதல் வந்ததும் குதிக்கும் குதிக்கும் சிறகால் வாரத்தை இடிக்கும் இடிக்கும் பூவா விரிகிற உலகம் உலகம் தரிசா கிடந்தது இதுவரை மரம் போல செத்து கிடந்தனே உன்னை பார்த்த பின்னே உசுறு பொழைச்சது சொந்தமா கிடப்பியா சாமிய கேப்பேன்
Brother asking for a movie treat again? Just sibling things. Send money with Paytm. For money transfer, Paytm karo.
மனசெல்லாம் மழையே நனைகிறேன் உயிரே என் நெஞ்சில் வந்து தங்கி சாரல் அடித்தாய் என்னாகும் உயிரே உயிரே என் கண்ணில் வந்து நின்று என்னை பறித்தாய் என்னாகும் உயிரே உயிரே இரவில் வந்தது சந்திரனா என் அழகே வந்தது உன்முகம்தான் வெண்ணிலவோ வாழ்ந்ததும் தேந்திடுமே உன் அழகோ தேந்திடாது வெண்ணிலா மனம் உன்னாலே பூ பூக்குதே மனசெல்லாம் மழையே நனைகிறேன் உயிரே வானில் போகும் பறவைகளாய் நீயும் நானும் பிரிந்திடலாம் உலகையே மறக்கலாம்
வேறு வேறு விண்வெளியில் மாறி மாறி திரிந்திடலாம் பறக்கலாம் மிதக்கலாம் காற்றாகி கை கோர்த்து போவோமே
முகிலாகி அங்கும் இங்கும் ஊஞ்சலாடுவோம் மனசெல்லாம் மழையே நனைகிறேன் உயிரே காதலாகி குறைந்து விட்டால் காலம் நேரம் மறந்திடுமே வானிலையே மாறுமே
ஏழு வண்ண வானவில்லில் 100 வண்ணம் தோன்றிடுமே யாவுமே மாயமே வெயிலோடு மழை வந்து தூருமே
முகிலாகி அங்கும் இங்கும் ஊஞ்சலாடுவோம்
மனசெல்லாம்
மெல்லினமே மெல்லினமே நெஞ்சில் மெல்லிய காதல் பூக்கும் என் காதல் ஒன்றே மிக உயர்ந்ததடி அதை வானம் அண்ணாந்து பார்க்கும் மெல்லினமே மெல்லினமே நெஞ்சில் மெல்லிய காதல் பூக்கும் என் காதல் ஒன்றே மிக உயர்ந்ததடி அதை வானம் அண்ணாந்து பார்க்கும் நான் தூர தெரியும் வானம் மீது பட்டாவில் இழுத்தாய் என் 25 வயதை ஒரு நொடிக்குள் எப்படி அடைத்தாய் ஹே, ஹே, ஹே.
disconnected. Paired.
உன் பார்வையில் பைத்தியமானேன், உன் வார்த்தையில் வாக்கியமானேன், உன் வெட்கத்தை வேடிக்கை பார்த்தேன் மயங்கினேன். ஒரு ஞாபக அலையென வந்து என் நெஞ்சினை நனைத்தவள் நீயே, என் வாலிப திமிரினை உன்னால் மாற்றினேன். பெண்ணாக இருந்தவள் உன்னை நான் இன்று காதலி செய்தேன். உன்னோட அறிமுகத்தாலே நான் உன்னில் மறைமுகமானே, நரம்பெல்லாம் இசை மீட்ட குதித்தேன் நானே.
Pleasant morning to everyone. Welcome to third day of our second ECP Con, International Conference on PharmaNext Global 2025, a convergence of innovation, integration and educational progress in pharmacy. Today, we dive deeper into knowledge through engaging technical sessions and keynote addresses. Every session becomes more meaningful when it is guided by an experienced academician who brings both wisdom and perspective to this discourse. To chair this session, we are privileged to have with us a distinguished personality. Our first resource person is Dr. B. Satyanathan, Professor and Principal, Apollo College of Pharmacy. He will deliver AI-driven breakthroughs in natural product drug discovery. As we move on into the session of our esteemed international conference, it is my honor and privilege to introduce who will be the chairing this session. So first, we would like to call Dr. G. Sumitra to introduce the person of the chair, Dr. V. Sivashankar, Associate Professor, Department of Pharmacy Practice, SRIPMS, Coimbatore. Please, ma'am.
Good morning, everyone. Myself, Dr. J. Sumitra. It's my immense pleasure to introduce Dr. V. Sivashankar. He's a seasoned academician and researcher with over 20 years of teaching experience in the field of pharmacy practice, currently serving as a professor in Sri Ramakrishna Institute of Paramedical Sciences, College of Pharmacy, Coimbatore. He has made significant contributions to clinical pharmacy education and pharmacoepidemiology. Dr. Sivashankar holds a B Pharm, M Pharm and PhD from the Tamil Nadu Dr. MGR Medical University, Chennai, and his experience lies in teaching advanced courses like clinical pharmacy and pharmacoepidemiology to PharmD and M Pharm students. In addition to his teaching roles, Dr. Sivashankar serves as a staff coordinator for the Patient Counseling Center at Ramakrishna Multi-Speciality Hospital, Coimbatore, where he plays a pivotal role in bridging the gap between pharmacy education and pharmacy healthcare services. He is committed to enhancing the quality of patients' care through the integration of clinical pharmacy practice in hospital settings. Dr. Sivashankar has published over 50 research papers in national and international journals, contributing valuable insights into clinical pharmacy practice and pharmacoepidemiology. He actively participates in academic community as a peer reviewer for several respected journals and involvement in the national and international conferences. His involvement in the national and international conferences has allowed him to present his research and engage in discussion on the latest advancements in the field of pharmacy practice. Dr. Sivashankar has dedication to pharmacy education, and his contribution to the clinical pharmacy discipline make him a respected figure in the academic and the healthcare communities. Sir, please, sir.
Good morning on all present here. First of all, I would like to thank the ECP College of Pharmacy management as well as Principal Sir Dr. Sambat Sir for giving me opportunity for introducing the speaker of the day. So without any delay, it is my humble pleasure to read out the biodata of Dr. V. Satyanathan. Dr. V. Satyanathan is a highly experienced pharmaceutical professional with over 21 years in academia and research, currently serving as a principal at Apollo College of Pharmacy, Tamil Nadu, since 2018. He earned his PhD in pharmacognosy from Tamil Nadu Dr. MGR Medical University, Chennai. in 2008, preceded by an M.Pharm with a specialization in pharmacognosy and Bachelor of Pharmacy from the same university. His doctoral research focused on the standardization and scientific validation of traditional Indian drugs involving comprehensive pharmacognostical, phytochemical, and pharmacological studies. Dr. Satyanarayanan has held leadership roles in including principal and dean at multiple institutions across India, such as Tirumala College of Pharmacy, Telangana, Arvind Daksha Educational Society, Telangana, Mother Teresa Pharmacy College, Telangana, and Rajasthan Pharmacy College, Jaipur. Along the administrative duties, he is an experienced educator in subjects spanning physical pharmacy, pharmacognosy, pharmaceutical analysis, microbiology, and industrial business management for both B.Pharm and M.Pharm students. Earlier in his career, he was a research scientist at Arvind Herbs and Research Development, overseeing herbal product development and formulation and standardization. Dr. Satyanathan has actively contributed to pharmaceutical science through over 20 peer-reviewed publications focusing on pharmacognosy, phytochemical standardization, antimicrobial and anti-cancer activities, and herbal drug validation. He has also participated extensively in national and international conferences, serving as a technical session chair, invited speaker, and oral presentation judge. His accolades includes the Best Researcher Award from ISAC 2019 and roles as evaluator and convener in various prestigious forums. He is also an editorial board member and external reviewer for journals such as the International Journal of Pharmaceutical Research and Life Sciences, and he is fluent in several languages including the English, Saurashtra, Hindi and Tamil. Dr. Satya advancing pharmaceutical education and research through innovation, scientific rigor and mentorship, making a significant contribution to traditional and modern medicinal plant research in India. With this small introduction, I invite V. Satyanathan sir for his session. Thank you.
Hello. Good morning. So everybody had breakfast. Have you had or not? So I'm very thankful to the management, principal, Dr. Sambat sir, ERODE College of Pharmacy, for inviting me as a speaker for the conference PharmaNext 2025. And I take a privilege to present my topic in AA. I'm a pharmacognosist. Why I chose AA is that because, first of all, I want to know what is AA. So, and second thing, whenever I meet students, I want to interact with them with the latest updates, because first I have to get updated, no? Then only I can update for you people. And in natural products, less. So in that way, I always try to contribute more on natural product, because I am basically from Captain Srinivasa Research Institute, Central Government Research Institute. I was a research scientist. More than academics, I was doing research products and standardization. So there are a lot of lacunas there. So that under how we are going to fulfill with AA. It will take a long journey in AA, definitely. So for that, first I have to know some basics, no? So for that, I just prepared something to present over here. So what is AI? Just students, artificial intelligence. What do you mean by that? What do you mean by that? The machine like computer, which is going to mimic the human intelligence. Okay, so anything, basically, before starting the session, even there are a lot of you would have seen in your net, like Facebook, or even while driving. When we are driving, what it happens? It shows the way. But that is not big AI, but whereas it also alert us that traffic is more in this area, or you just take a diversion here. So these are all somewhat a small intelligence program made from the people, okay? Okay, here. So my topic is AI-driven breakthroughs in natural product drug discovery. I took this topic for easing phytodrug research because my main forum is phytodrug research. Next. So phytodrug, as we know, when you are studying in pharmacognosy or HDT, the three words always you have to remember what? That is quality, safety, and efficacy. The same thing whenever phytodrug, when you are going for research, it involves investigating medicinal plants for what? We are not going to deal only with botany plants. We are going to deal with medicinal plants. What do you mean by that? Definitely it should have therapeutic efficacy. This field explores the chemical compounds within plants, pharmacological properties, and potential to treat various diseases. So research includes mostly identifying active compounds, mechanisms of action, and how to prove their efficacy with clinical, preclinical, and clinical efficacy. See here, while dealing with the natural product research of phytochemistry, lot of time-taking process. The AI, mostly the AI, why they are included in all the industries, now the corporates are working more on AI, because these tools, what will do is that the redundancy, that is the, it will save more time with more, they can make more money, no? Because definitely it is we have to put, it is very expensive. We have to put a lot of money. But many corporates, many industries, they are ready to put that much money, because if you put more millions, you can take more 5 times than trillions. That also within short time. That is the main thing. With accuracy, with precision, because a lot of statistics and probability roles are playing for all the languages of AI. So here, how to use these things? For this today presentation, just I want to say about deep replication using multi-omics data analysis and the polypharmacology concepts of phytochemicals. So with these three things, how we are going to make it easy with our tool called, our toy called AI. Next. So what is dereplication? Very simple words I have used here. Identifying known compounds. So dereplication is the process of identifying known compounds in natural products. See, to avoid redundancy, there is lack of time, because doing column chromatography or whatever, you are making a lot of molecular research, phytochemical research, it is very time-taking process. When you are going for a lot of traditional methods of techniques, a lot of known compounds will be coming, first of all. So these known compounds, see, for example, if you put most of the plants, if you show in GCMS, it will show some long fatty acids or the basic alkali chain, furan chains. Like that, many things will be coming. It is already known compounds will be there, known activity already, it is established one. So in this thing, definitely the time is wasted. So if you want to search a novel drug, this will make more time. The known compounds will be coming on, no? So how to just filter that and go to an all drug? That is the main thing of AI, that is called dereplication, okay? So importance of phytochemical research in that is dereplication is efficient drug discovery and development from natural resources. And AI enhances the speed and accuracy. As I told, speed with complete accuracy is the total motto of this AI for industries. Next.
Disconnected.
So these are all some replication methods used traditionally. You would have heard in your books. You have seen chromatography techniques like HPLC, GCMS, LCMS, spectroscopic methods, nuclear magnetic resonance, UV visible. All these things, what is happening? Time consuming and lot of expertise, labor. It is intensive with more labor work. So how we are going to use this AI to make this ease. Next slide. So this is the basic thing I have given for students level. AI technologies use machine learning, deep learning, pattern recognition. This is the basic concepts you have, all the people should remember to mimic the way of human intelligence. First, the machine should learn. We are using machine means computer because whatever we are going to speak with computer only. And computer itself should speak first of all. For that, definitely the mathematics with computer language is necessary. That is the set of instructions called algorithm. In school, you have studied about algorithm. These instructions, this machine learning, what it will do, it will form all these sets of data to make model using algorithm. So it will form algorithm itself, you understand, and it will form lot of models. Even this model, this machine learning also having its own intelligence, which we want, which we can take from the recycle bin, whichever already it is not allotted. Everything it will concise. So that is the specialty of this machine learning. Deep learning, the next thing. First, the machine is learned. After that, when we want to work our particular science or whatever we want to work, the complete data should be analyzed, interpreted. Everything it should be fed first of all. It should be trained already. So that is in deep learning, the images, whatever your structures or whatever binding, protein, everything, so the structure, sequence, everything will be read. How it will be read? It will be like a neural network, like our brain. How the human brain, lot of notches, you have a lot of turns and twists in your brain, fissures you say. So like that, lot of here neural network will be there. That neural network is going to collect all the data. Can understand? From the data only we can read that. So if you see about this deep learning, there are called CNN and RNN. CNN means convolutional neural network. This will see all the edges, nook and corners of the data, and it will try to give the precision more, this particular convolutional. Wherever this, after this convolutional, the recurrent neural network, what it does, there will be a lot of sequential data will be analyzed, but all the sequential data will be made into specific sequential output. So when you are giving input, if it is not sequential and it is not specific, so everything will be converted into specific sequential output data using the recurrent neural networks. What is deep pattern recognition? The name itself implies. It also sees the angles, the distance, everything, and the pattern precise. It will make more accurate. So this is a basic thing which our brain also doing. When I read about memory, I don't want to say today because that is another topic. So it also shows how we are going to observe, how we are encoding, before decoding, how we are encoding that. And what are all the processes involved in our brain, how we are going to assume, how you are going to take, how you are going to observe, already known, not known, I don't want. So all the things we are putting in our brain now, after that we are answering. The same thing here also it's happening. Okay, and these languages like semantics, syntax, because commands should be there. Without commands, we can't speak with the computer. So if we want to speak with the computer, we need commands. For that, syntax, semantics, everything is used. Annotates of these semantics also is used. This is mainly programmed, the language called Python. The Python, you would have heard that. This is a very good programming language. So most of this particular, when I read, I saw most of the the language is used here is Python. And the basic C++ in Arctic and many things. And there is a term called Python. That Python is nothing. It is annotates of these Pythons. Understand? And there is one thing called garbage memory. See how not only recycle is a very simple thing. Garbage memory, the Python what it is doing in that program, it is also searching all the data, whichever we have already reported. From that garbage also it is searching. In that searching and whatever, something related, that data is also putting in that. Once again what happens, this neural network, in this neural network only we are going to put a lot of millions of data. It should be trained. We have to train that completely. The neural network is getting trained. Then the convolution becomes recurrent. The specific data is occupied. We can speak with that language called Python, and the answer is reported thus. Can you understand? So the basic thing I want to say, and already the benefits, once again, increase speed, accuracy, these things. Here, if you see the chart, the input data, if you want to find something about a molecule, already it will be fed the machine. It is searching the data, all the algorithms, okay, and it is giving a model of things. The prediction is done. Once again, go for evaluation, give to the machine, give another training. Once again, it is forming a lot of algorithms inside, making a model, much more clarity. Once again, it is sending. Like the training data, so all the things are getting fed. ரொம்ப simple பா, feed பண்ணி வச்சுக்கிறோம் அவ்வளவுதான். எல்லாத்தையும் feed பண்ணி வச்சுக்கிறோம். கேட்கும் போல நமக்கு முக்காவாசி வேலை மிச்சமாகுது இவ்வளவுதான். But for that, expertise is necessary. I used to say to the students, information technology, last 20 years going on, you don't think information is the system. You want to ask question, for that information should be here. To ask question, human brain is more powerful. First you learn the basics, okay? I'm not saying computer, whatever, pharmacy, engineering, whatever. To ask question, you should have more knowledge than the supercomputers. Next. There are some basic examples: cannabidiol, verbenol, chloride, quercetin, epicalus, catechin, tannins, resveratrol. Some basic examples I have given just to know some terms like AI-enhanced HPLC analysis, AI-driven LC mass, that is tandem, spectrometry analysis, neural networks for metabolite profiling, deep learning pattern recognition, and the uses are given. These are some basic examples how AI enabled in phytochemical research. Next. This is an example in a phytochemical that is flavonoid. It has broad spectrum of activity, you know, and this mainly of lactone rings. See here, if you have known about basically using Schrodinger or something for computation in silico methods, you would have known this about the speed ADME and all. There are a lot of ADMET lab, ADMET SCAR and all. There is more powerful tool than the Swiss ADME. So what it is going to just you understand, this flavonoid compound using these smiles, it will convert into smiles. That is like we can say simplified molecular line entry program like that. It will be confirmed, or even spectral data. It will be totally. It will be making a file like that, and it will make. Okay. So from this you can study toxicity, physicochemical. Many things are there. Next slide we can see that. Previous. Before. So using docking simulations, what we are doing, the binding affinity of the generated flavonoids to the target, which target enzymes or which target you want. According to that, this generated flavonoids, the binding will be studied. I think you would have did it in your project. So all these structures are refined here. And a lot of tools are used. As I told, some tools about tools, machine learning libraries, TensorFlow, PyTorch, Sidelight, scikit-learning. Scikit-learning is a Python program. And if you want to see this TensorFlow, PyTorch, how to keep in mind the flow, the scalability, the flexibility, you should understand all our complex data. Even human brain is having a lot of complex data. We can say like big data, more or less. Big data. We have studied, heard in computer science. This big data, it will be complex of data, known, unknown, predicted, unpredicted. Can you understand? So like that, lot of complex data will be there. So here will be like notches. You can say like knots, a thread how you are going to remove. If you want to make a lengthy thread according to large scale or small scale, that thread, the knot should be removed. Can you understand? The same thing it's doing TensorFlow, PyTorch and all doing that only. PyTorch is mostly doing for small scale and TensorFlow somewhat for a large scale. And there is another thing called Keras for prototyping likewise. So these are all some tools here. Cheminformatics, if you know about silico studies, you would have known better than me. ADKit is once again a Python C++ program, and all for chemical informatics, Babel. These are all we can get the chemical structure, spectra, all the data. Docking software, Autodock is much more better. And Schrodinger is very useful mostly for the biological, biopharmaceuticals, our pharmaceutical industry likewise. NLP means natural product libraries, Spacey and NLTK, that is natural library toolkits. So here Spacey is once again NumPy, Spacey, these are all you would have heard in Python. Okay. So what it does, from this docking, whatever the target, the molecules, once again we are going to synthesize, and this synthesis is used for finally to improve all AI models. We are going to train that, we are going to feed that inside. That is a basic flowchart here. Next. It's a very simple example I have given. See already when we are the phytocompounds in Acidirecta indica. What is Acidirecta indica means? Neem. See there are a lot of molecules. Just for example, I have taken this using GCMS already when they studied. Some 4 compounds already, they have given all the, it is already established one. The 5th compound, tridecanic acid, We don't know what is the new molecule might be, but it's not a new molecule. It's a very well-established antibacterial. But for example, I took this slide, okay? So it is no activities found. So it's a novel molecule might be. So how I will read that? That I want to show that in next slide. See here, tridecanic acid. It's a fatty acid, 1 second saturated fatty acid. So this, it's a complete prediction. Prediction is done, various targets with various targets, and went to clinical, preclinical, already established or newly established, whatever all the studies are done. See here, the metabolites of the tridecanic acid. See, when we see about metabolites, means biologically it is having acetyl-CoA, some mechanism, but here, what it is showing, actually the structure is not clear here. If you want to make this particular chemical, whether it is binding exactly or giving more affinity, or you can also select these structures, similar structures. For example, tridecanic acid, similar structures, you can add trimethyl or benzyl derivative or lauric acid, palmitic acid, myristic acid, tolmeric acid. All these things are somewhat similar in the structures. So these structures can be kept for binding. So which is better? That can be concluded for the therapeutic efficacy and sent to the all preclinical, clinical studies, everything. And everything will be fed in the AI data. That only I want to show this. Next. So supervised learning and unsupervised learning. What is supervised? It's mentioned like labeled data sets. In radioisotopes, you would have studied labeled. What do you mean by that? Standards, references. Already with the labeled data sets you can work on. Or here unsupervised, unlabeled data. That also you can work on. And I already have discussed about CNNS, convolutional neural networks, and RNNs. Here mainly these neural networks, here our phytochemical study, this N number of NMR data, everything will be pulled out. And everything will have been trained inside the neural network. Okay, next. This is general workflow. All the system work, it will be like this only. Gathering large data sets, cleaning and normalizing data. See, everything, the filtration, or this not only filter, if this language itself, it is doing that also. All the kits is having this cleaning and normalizing data. And model training, using the standard labeled data, you can train AI models. The algorithms can be formed, fed, trained, that is the meaning. Prediction and analysis, apply trained models to new data. And validation, cross-referencing with all the predictions and with already established accuracy. The traditional things we have did, not traditional methods, whether it is coinciding with that. So whether the accuracy is getting nearer or not, likewise. So here you should not forget, the traditional method, whatever you are doing, there should be no misconception. Can you understand? Fault. If that is fault, the entire this logic toy will show all fault result only. It is a very great disadvantage. So always expertise. Definitely, the expertise people are going to live for long. Okay, next. This is another very simple flow chart. You are collecting the plant, you know, a lot of extraction methods in cognitive you have studied. So all these things, we are going to work. The next step I told multi-omics. Multi-omics, you know that all the complete set, for example, set of genes or RNA, whatever. Likewise here, molecules, metabolites, you say. Most of the metabolites are byproducts of enzyme, likewise. These are all small molecules. You can think this metabolites, I told about tridecanic acid, one example I showed like that. Lot of small units are small molecules. So these small molecules, we need lot of hypernetic techniques. Like supercomputer, we need lot of coupled high resolution instruments. Okay, then we can study that. So that is called metabolomics. Okay, this is basic metabolomics. I think you would have known that. Small molecules, generally it will be calculated in Dalton. Dalton is somewhat like, you can say like less than 1,500 Daltons they have mentioned. So it is 1.56604. See, near to that you can say like Avogadro number you would have heard in your school. It will be very, very small. I can say in atomic mass units it will be somewhat less than 0.001 sometime atomic mass units. But here, this particular type of analysis, high resolution FT, that is Fourier transform mass with NMR, all these sophisticated instrument will analyze that analyte nearer to this 0.001 atomic mass unit. That much accuracy, that much precision or nearer. Even NMR, you know that whatever the small molecule change, hydrogen, carbon, wherever small changes also, it will be processed very exactly. So that is the specific, special point about NMR. And about metabolics, PharmaNext, you should understand there are a lot of statistical data. We use generally ANOVA. What is ANOVA? Analysis of variance. But here, lot of 2 or more variables will be involved. So they will call MANOVA, that is multivariate analysis of variance. Like that, lot of statistical data. It will work on logistic clustering, logistic linear regression, like that, lot of things are there. You can understand, it will be that much precise one, because statistics, you know that it is not a fact, but it's very near to the fact you have to get in. Mostly in molecular, our chemistry, or even in clinical study, the accuracy should be that much more, no? So here, so they are using the quantitative differential expression analysis, as I told, multivariate analysis. That much statistical data will be involved. Here, what is here, right and left, you understand already I told, it is trained, all the NMR data are trained. If you want metabolism, all the metabolic, that small molecules, spectral data, chemical details, everything is trained. If you want genomics or proteomics, if you want the gene pattern to study or sequence of protein, that also it is completely fed here, trained here. All the libraries are available. For example, NAPROC, C13, NMR, all the data is inside for the natural product. NMR shifted database, and BML is something like our biological metabolism. That one is ready here, okay? Even here, biological, that is magnetic resonance bank. Like that here, if you see all the mass bank of North America, Metlin, GMPS and all, for natural products, and HMDP, that is human metabolism. Okay, all the protein banks, everything is fed. So that only I want to say here, the extraction, after extraction, the small molecules are studied using data from this NMR or genomic, whatever, all these small molecule studies. It is already previously trained. From that you are using the very closer or very near mathematics, that is called statistics. And finally you are going for optimization. Next. So advantages, once again, efficiency, not only efficiency, scalability. That is very, very important. As I told, if you don't know to search also, it will search and give maximum, as I told, from like filter or even garbage, everything, okay? And it is cost effective, as I told, definitely you have to put a lot of money, but you can take more money than what you are putting, at least 5 to 10 times. That is the main motto of all the corporates now. Next. Drug-like filter. Here a small tool, drug-like filter, likeness filter, or drug-like filter. So a deep learning framework of multidimensional drug likeness. See, multidimensional. This filter is going to work in all the type of nook and corners, like multidimensional. And we can say here, as I told, this is very much useful in drug development. And not only the new one, even already existing candidate drug also what it can do. It can search any doubts you can there, you can go for that search. It will try to filter from a lot of, it is having GA. GA means GA use generative AI. Okay, so a lot of universal data are there. From all the data, it will try to filter and give you. So a deep learning based framework that evaluates drug likeness of compounds across multiple key dimensions. And understand, it is going to give you data, completely what you want. Can understand, it is going to give the drugs, even sometime it is unsimilar for your search, that it will try to neglect and try to give you the maximum which you want. Purpose to streamline and automate the filtering of large common libraries for viable drug candidates, as I told, already existing candidates also. Key advantages, fully automated, scalable, multidimensional evaluation, reduces time and cost, and it is open access, as I told. It's not only for new drug, even established drug also, if you want, you can collect. Okay, next. How it works with this multidimensional aspect. Physicochemical rule evaluation, you would have known about a hydrogen bond and molecular weight, everything. You would have studied in silico. So evaluates core drug properties, molecular weight, lipophilicity, hydrogen bond, donors, acceptors. I think nearly 15 physicochemical properties are there. And Lipinski rule of 5, you would have known about rules, some 12 rules with substrates, as well as the rules for this. Generally, this physicochemical, for what you are going to study, the chemicals, whatever you want to work on, how these metabolites or chemicals are going to work in your system, that is in biology. Okay, for that enhances prediction of oral bioavailability, everything is there. Toxicity alert, investigation, this filter, drug-like filter, how it is using protox to stop tox, of hepatotoxicity, mutagenicity, everything is there. So when you are going to admit studies, what is admit generally? absorption, distribution, metabolism, elimination. This particular data is already it is there. A lot of libraries are there. As I told, most of the libraries are from this Python, C++ basic, and even harmful leads will be studied. It is not just the pharmacokinetics, so even the harmful leads, this particular substrates is already existing harmful. For example, I have studied some phenothiazine derivatives. It is having already acute toxicity. Wherever if you study meclorethamine, it is having genotoxicity. So already established also it will be giving. So that we can search with our substrate, okay, we have to neglect this. We have to go to the next structure. The binding, though it is having good binding, we can neglect that. The filter is showing us. Can you understand? So like that, if you see about binding affinity, binding, you would have heard about hydrogen bond, everything will be used here, structure-based docking. There are some examples for, we have given for SARS-CoV-2, that is Emperor enzyme, Kaga enzyme, or FABH fatty acid enzyme, like that. They have some examples I have given here. Even molecular dynamics simulation is there. A lot of people are working on that. Okay. And here, mainly in chemistry part, I want to say about synthesizability. See here, this using the filter, we can also find out the synthetic route of the chemicals, because everything, it is not possible. Sometimes it is very difficult to synthesize. It is not possible. In that way, we can find out the lead compound by the building of blocks, like building of blocks, you just consider, the blocks will be broken into a simpler thing. So reverse, retro means what? Retro means something like a back one. So you can go back, search, and finally the lead compound can be found out. You can enter from the lead compound, from that also we can frame to change. From that also we can frame to change, or this particular structure will be before this structure. Like that you can also filter, the filter will be very fast. You can use like that. Okay, next. So this rule already we have known about, a lot of toll rules are there, Lipinski, Weber, Yogi paints like that. And here physical property based on molecular weight, TPSA, atoms, hydrogen bond, acceptors, donors, like that you would have learned already. So all these things, even there are a lot of violations and all there. I think you would have known these things. Okay. So all these things from this library, everything will be formed, and this can be, the data can be taken from that triangular filter. Next. So there is the first thing, the previous slide, down I have given one particular link. In that link, if you go directly that website, you can get a lot of, a number of data of this drug-like filter. The toxicity, as I told, preclinical toxicity, and even the clinical toxicity already established, and both can be compared with all these substrates also. That is the best one here, the substrates, because this AI, the neural networks, whatever, it is not only accurate, it is also linear, you can say, non-linear things like that. So in non-linear things, it can also search beyond our thinking. It will also try to give a lot of information in between like that. Can you understand? So like that, all these substrates, everything. And here there is one thing called cardiotox.net. If you go in that, complete cardiotoxicity it is showing that. Can you understand? So nearly 600 alerts of this toxicity are given. Next. So it is dual path analysis, protein structures. You can see how the ligands and the sequence also is there. As I told, all the docking programs, pipe interactions, hydrogen bondings, hydrophobic, all this. Okay, and finally, you can go for which you want model, whether this is right or wrong, like that. You can just select, you just assume that, because I'm showing very fastly to just assume how the filter works on. Can you understand? Next. Common synthesizability. As I told, retrosynthetic route, if even all the smile data it is given in route information, and from this back routes, as I told, from garbage, from filter will give all the even linear things also, all the things we can study here. And there is one thing called retro star. So in that retro star, if you click, it is not exactly star, something like asterisk it is given. So when you click that, it is showing all the routes, like small breakups. So it is like I told, like under R3. See here how the blocks, if you break that, it is getting simplified. So you can find out whether this route will be correct, whether this block only is going to make that block. Like that, you can just make it fast. Can you understand? Next. So AI duplication, here I'm showing some breakthroughs here. Streamline natural product development of natural product based formulations using active compounds. Okay, quality control, not only product development, quality control, because I'm basically from standardization. There are a lot of studies there. ensure consistency and quality control of phytochemical products. You can continuously monitor, analyze. If any change is there, you can feed that. Innovation, drug discovery. Yes, of course, I told a lot of drug discovery. Mainly, it's going for repurposing drugs and antimicrobial drugs. It's going on research. So novel compounds can be found out by de-replicating technique. And case study. See, I've given some example. A new antibiotic recently found. You see, it's a macrolide. That is symplocolide A. This is one particular drug that is already, it is mentioned, marine natural products. Just I have given one example from marine natural products. Through what way CNN-based NMR tool, they have found using this de-replication. So known compounds fast they have segregated, and a novel macrolide was been found. Can you understand? And symplocolide as well as phenolide. That chimeric also they have found in that way. Next. Another good example, if you see in the research, lot of high throughput screening, hit and lead. How you are doing that is same hit and lead molecules. It is feeder. Pattern can be recognized. Spectral analysis can be done. Data mining and integration can be done. Here I have given one case study example. A potential example from a plant called Colibrucia oppositifolia. இது வித்து பஸ்தலைன்னு சொல்லிட்டு ஒரு செடி பாது இது மெயினாக இந்த நம்ம ஊரில் இல்லை போர்ச்சுகீஸ் செடி AI assisted de-replication could be a novel compound plant known using de-replication strategies. And the compound நீங்க பாருங்க, it is anti-inflammatory. What is that? 5,6,7 trihydroxyflavone glucuronide derivative. So இதை கூட நம்ம கண்டுபிடிச்சிருக்காங்க. So it's one breakthrough. Next, therapeutics. See, when we talk about phytochemical chemistry discovery, even therapeutic, I told safety efficacy is very important. Before going to preclinical or clinical, this should be completely studied. Now here, one beautiful thing from this AI, we can go for precision medicine. See here, how it helps in identifying phytochemicals. It can be tailored for personalized medicine. What do you mean by personalized medicine? See here, precision medicine or personalized medicine. Which generally what we are thinking, if the people of one particular population getting cancer, the reason is same like that we are thinking. And the drug also will be same, the diagnosis is same. But it's exactly if you study the gene pattern or protein sequence, everything, and which is targeted. According to that, if you go back theory, the history, if you know about the history of a person, definitely the change will be there. Am I right or wrong? Exactly the same reason. For example, I will show in my slide, everybody is not going to die within 5 years. Somebody is going to live 10 years. Somebody is living for 2 years after cancer. Am I right or wrong? If you are getting cardiac stroke, the same thing. So why it differs? So it is not only, so if you use a diagnosis in a similar same way and you are giving the same medicine, it is not correct. So in that way, when you think this AI is very beautiful, that it is contributing to the medicine called precision medicine. Phytochemical libraries and databases, I have already told. Even synergism, see, most of the Siddha, Ayurveda, whatever, if you go for the plant phytochemical, synergism is the main thing. You know what is synergistic? What is that? Combinability improvement will happen. You know that, no? So synergism due to like a catalyst or sometimes inhibition of the enzyme may take absorption, it all differs. When two drugs are given, what happens? It is increasing the activity. Am I right or wrong? So silent for just 5 minutes. Pa? So like that, this synergism also, that type of thing also you can feed and you can get the data from AI fastly. And the case study, like cancer cells, one example given. Next slide. There is a new flavonoid called isoramnatin 3-galactose, okay, derivative from Marcophytum marti. See, the market element is kaatavari. It's a new molecule, use the same re-replication techniques. Here what you have to see is that, see, HRESI, electrons free ionization la use pannirukanga. And the coupled, that is hypernetic technique is used here. And you know what is the significance, as I told, the optimization and the accuracy and fast everything. And this, you see, it is evaluated for various types of cancer lines. That also beautiful here. Next. Well, just be silent. See here, as I told previously, here, genomics, like a multi-omics, no? Not only I told not only metabolomes, even genomic, proteomic, whatever you can take. Using this, make all the algorithms of a normal, healthy controls, as well as cancer patients. So all the things, everything it is fed here. The data are available. Various algorithms formed and the data are available in the neural network. And you also see here some patients, as I told, the survival probability is different. The prognosis, that onset of disease is different. With that, you can find the therapeutic targets. The therapeutic targets may be protein or for the particular target of protein, which is the metabolite. Like that, when you study the precision medicine and as well as the very good, the novel compound for cure exactly for the patient, not exactly for one particular, all the patient, it is for beneficial for the specific patients, like specific medicine like that, okay? Next, we silent. So it's a simple thing like how we are going to collect from the blood, all the data, proteins, genomes, என்னென்ன வேணுமோ எல்லாத்தையும் கலெக்ட் பண்ணி வச்சுட்டு ஃபீட் பண்ணுறது. As I told, data, எல்லா டேட்டா வந்து சிம்பிளாக இருக்காதுப்பா, big data. All the data are very complex mixtures. These data are simplified. Algorithm is formed. And what is cloud computing? Using internet, you can get the server, whatever storage. If you want net, everything, you can just get from the net itself. So all the things are stored, and you can go for integrating the precision medicine which you want for a particular person. Okay. Next. It's a network pharmacology. I think next sir will give a broad topic about this. But generally what I want to say here, you just see this compound, protein, gene, disease, silent. When you are doing docking, also the same thing. The compound and protein interaction will be there. Can you understand? So like this here, compound, protein, gene, disease, integrating genomics and systems biology with computational tools, and using natural products improves outcomes in drug repurposing mainly. Here you are given a lot of limonene, medicine, alpha-type pinene, இந்த மாதிரி டெர்பின்லாம் கேள்விப்பட்ட டெர்பின் தான் கொடுத்துருக்கேன். நீங்கள் நல்லா பாருங்கள், இது ஒரு யூஸ் தான் இருக்கா? நமக்கே தெரியும், ஒரு பிளான்ட் எடுத்திங்கன்னா ஒரு சிதறக்கு எடுத்திங்கன்னா 1000 யூஸ் சொல்லுவோம். அது வந்து multi plant with multi compounds. If I take a single curcumin, that also I can't say only in anti-inflammatory, நித்திர முடியாது, அதுக்கு anti-cancer இருக்குன்றான். Cancer itself a network of hundreds of diseases. So there is a network chain, see here, ஒரு இதுக்கு எவ்வளோ ப்ரோட்டீன் நெட்வொர்க் இருக்கு பாருங்க. ஸோ அதுக்காக தான் அதை ரீபர்பஸ் பண்ண முடியும். ஸோ நவ் த லாட் ஆஃப் ரிசர்ச் கோயிங் ஆன் ரீபர்பஸிங். கேன் அண்டர்ஸ்டாண்ட். இப்போ இன்ஃப்ளமேட்டரி மட்டும் கிடையாது, அது கோவிடுக்கு ட்ரை பண்ணி பார்த்துருக்காங்க. அந்த மாதிரி லாட் ஆஃப் எக்ஸாம்பிள்ஸ் ஆர் கமிங். ஸோ இது பேசிக்கலாக ஆஸ் அ காக்னிசிஸ்ட் ஐ ஒர்க் இன் சைலண்ட்பா இந்த சித்தா ஆயுர்வேதில் ஒர்க் பண்ணதால சொல்கிறேன். அந்த கான்செப்ட் நம்ம அப்புறம் பார்ப்போம். ஆயுர்வேதி கான்செப்ட்லாம் எல்லா மெடிசன் மாலிக்யூலு நல்லா தெரிஞ்சுக்கிங்க. அவங்க மருந்து கொடுக்குறாங்கன்னா 40 இருக்கும். அந்த 40ல் எவ்வளோ காம்பவுண்ட்ஸ் இருக்கும், அப்படி தானே? ஒரு 10 மிக்ஸ் ஆகிருக்கு, நீங்கள் பார்த்துருப்பீங்க. ஆனால் அவங்க கொடுக்க மெடிசன் உடனே க்யூர் ஆகாது. ஸோ த லாட் ஆஃப் திங்ஸ் ஆர் தேர் லாட் ஆஃப் ஃபங்க்ஷனல் குரூப், டிஃப்ரெண்ட் ஃபங்க்ஷனல் குரூப்ஸ் வில் பி மாலிகுல். ஸோ டிஃப்ரெண்ட் ஃபங்க்ஷனல் குரூப்ஸ் வில் ஹாவ் டிஃப்ரெண்ட் அஃபினிட்டி டுவர்ட்ஸ் தி ரிசெப்டார். கேன் அண்டர்ஸ்டாண்ட்? அந்த ஒரு பர்டிகுலர் ரிசெப்டரில் வந்து இட் நல்லிஃபைஸ் தி சைட் எஃபெக்ட்ஸ் அப்படின்னு ஒரு கான்செப்ட் இருக்குது கெமிஸ்ட்ரியில் பேசுறது. இப்போ ஜென்ரலாக நீங்கள் வந்து when you say about the air, அந்த ஒரு மருந்து தான் கொடுக்குறான். அந்த மருந்து நீங்கள் 40 நாள் எவ்வளோ நாள் சாப்பிட்றீங்க, அப்புறம் சரியாயிடுச்சுன்னா என்ன அர்த்தம்? அவங்கள பொறுத்த வரைக்கும் என்ன அர்த்தம்? வாதா பிதா கபா பேலன்ஸ் ட்ரைதோஷா அக்கார்டிங் டு பிரகிருதி நேச்சர். வாட் இஸ் பிரகிருதி? நீங்கள் பிறக்கும் முதலே உஷ்ண உடம்பு சீத உடம்புன்னு இருக்கும், அதுக்கேற்ற மாதிரி தான் பேலன்ஸ் இருக்கும். அது பேலன்ஸ் ஆனால் தான் நீ சரியாயிடுச்சுன்னு அர்த்தம். அது கேன்சர் ஆகட்டும், டயபெட்டிக், பேர் என்னன்னா இருக்கட்டும். இங்கே வெரி குட் தியரி இந்த நெட்வொர்க் ஃபார்மகாலஜி இப்போ தான் இவங்க சொல்கிறான், நானா பார்ட்டிகல் இப்போ இவங்க சொல்கிறான். அவங்க எப்பயோ இதெல்லாம் சொல்லிட்டாங்க. அதே மாதிரி this network pharmacology already existing. Nalla thenjinga, I have a concept which I am working on. Now I am getting some type of proof also from old and traditional medicines. When you are sending to shoot a person or whatever you want to occupy a near country, அப்போ ஒரே ஒரு மிலிட்ரி மட்டும் அனுப்பிச்சா பத்தாதுப்பா. நேவி அனுப்பணும், ஏர்ஃபோர்ஸ் அனுப்பணும், ஸ்பை அனுப்பணும். and you understand there is a theory like that. அந்த மாதிரி தியரியில் தான் the Ayurveda is working. If you try mechanism, if you ask some pharmacology teachers, you just work on any type of medicine, then you see how the mechanism is going on of each and every compound or every plant, how they are mixing. அப்புறம் நான் சொல்றது கரெக்டாக இல்லைன்னு தெரியும். So I'm just working off my own, that's my interest. Next. So this is a basic flow chart. So metabolic analysis எல்லாம் metabolic analysis பண்ணி வச்சுட்டு ஐடென்டிஃபை பண்ணி குவாலிட்டி குவான்டிட்டி எஸ்டிமேட்லாம் பண்ணி வச்சுட்டோம். இது ஒரு பூலில் போகுது. இந்த பூல் என்ன நடந்து பாருங்க, நெட்வொர்க் பயாலஜி, பாலிஃபார்மகாலஜி, நெட்வொர்க் ஃபார்மகாலஜி எப்படி போகுதுன்னா, இது இப்படி எடுத்துங்க. காம்பவுண்ட் ப்ரோட்டீன் நெட்வொர்க்கு, அசஸ்மெண்ட் ஆஃப் டிசீஸ், அதுக்கு இன்டர்லிங்க்டு. ஆல் தி பயாலஜிக்கல் டார்கெட்ஸ் ஆர் ப்ரிப்பேர்ட். ப்ரோட்டீன் இன்டர்பிரேஷன் அனலைஸ் பண்ணுறாங்க, ஸ்டாட்டிஸ்டிக்ஸை கன்ஸ்ட்ரக்ட் பண்ணுறாங்க. திருப்பியும் அந்த பூலில் போகுது, இது காம்பவுண்ட் ப்ரோட்டீன் நெட்வொர்க்கில் போகுது. திருப்பி கோயிங் ஃபார் டிசீஸ், இன் பிட்வீன் மை மெட்டபலைட்ஸ், கெமிக்கல், ஃபைட்டோகெமிக்கல், அதுவும் உள்ள போய் பார்க்குது. இதெல்லாம் டேட்டாலாம் ட்ரைன் பண்ணி வச்சுட்டு வச்சுங்களேன், நமக்கு ஃபாஸ்ட்டாக யூஸ் பண்ண ஆகுது. இவ்வளோதான். நெக்ஸ்ட். ஸோ ரோல் ஆஃப் நெட்வொர்க் இது கொஞ்சம் ஃபாஸ்ட்டாக போயிடுறேன். அதிலே இருக்குது மேப்பிங் இன்ட்ராக்ஷன் பண்ணோம். I mean duplication and dereplication. Okay, regulatory insights, regulatory mechanism of phytochemicals, high throughput analysis, high throughput screening analysis, biological pathways and study பண்ண யூஸ் ஆகுது. Drug discovery integration using the genomics integration, all the things, systems biology எல்லாம் பண்ணலாம். enhancement, novel phytochemical associations. இங்கே ஒரு எக்ஸாம்பிள்ஸ் கொடுத்துருக்கேன். This is synthetic example but well known, so I want to just add in this. See, bacitracimab, இது ஒரு COVID-19 யூஸ் பண்ணியிருக்காங்கப்பா. It's a very good arthritic drug, but see, they have repurposed for what? COVID-19. The MIT researchers using machine learning algorithm, Alicin or drug, that's a diabetic drug, but they are used for many strains of bacteria. It was working. It's an example, synthetic examples for repurposing. Here just I want to say about MIT researcher. Most of the toolkit or most of the language program, license na MIT. What is MIT? நீங்கள் பேசினீங்க சொல்ல டாப்பிக்கை மாற்றுறேன். வாட் இஸ் எம்ஐடிப்பா? இதெல்லாம் தெரிஞ்சுங்க. என் பசங்களும் சொல்கிறேன், எங்கள் ஸ்டூடெண்ட்ஸ்க்கும் சொல்கிறேன். மேத்ஸ் டெக்னாலஜி ஐஐடியில் நல்லா படித்து டாப்பில் வந்தான்னு வச்சுங்க, ஐடி போகிறதே கஷ்டம். ஃபஸ்ட்டு போகிறவங்க எல்லாம் எம்ஐடி தான் போவான், வேலைக்கு போக மாட்டான். 1 லட்சம் 2 லட்சம் 5 லட்சம் 1 கோடிலாம் 5ஆவதுலேருந்து தான் போவான். ஃபஸ்ட்டு 2-3 பேர் எங்கே போவான்னு கேட்டிங்கன்னா எம்ஐடிக்கு போவான். எல்லா ரிசர்ச்சும் எம்ஐடி நடக்குதுப்பா. உலகத்தில் எல்லா ரிசர்ச்சும் எடுத்துப்பார், எம்ஐடி லைசன்ஸில் இருக்கும். அந்த மாதிரி இதையும் நேச்சுரல் ப்ராடக்ட் எடுத்து நான் ஏஐ பார்த்தாலும் எம்ஐடி லைசன்ஸ் தான் இருக்குது. நெக்ஸ்ட், ஸோ திஸ் ஆர் சம் நெட்வொர்க் ஃபார்மகாலஜி டீரெப்ளிகேஷன் டூல்ஸ். அதிலே பேர் எழுதியிருக்காங்க. யூ கேன் சி ஸ்டிச் கெமிக்கல் ப்ரோட்டீன் இன்ட்ராக்ஷன்ஸ்க்கு, சிடிடின்றது கெமிக்கல் ஜீன் ப்ரோட்டீன் டிசீஸ் இன்ட்ராக்ஷனுக்கு, ஸ்விஸ் டார்கெட் ப்ரெடிக்ஷன் ப்ரோட்டீன் டார்கெட்ஸ் ஃபார் ஸ்மால் மாலிக்யூல்ஸ், database binding affinities, identification of phytochemical protein interactions, and metabo analysis முதல்ல காட்டினேன். அது என்ன பண்ணுது பாருங்க, metabolic data analysis and functional interpretation, and NPAS and natural product activity, and species source database என்ன கொடுது, biological activities and species sources. நிறைய botanical sources இப்போ ஃப்ளோராஜெனிகா, plant AI, அந்த மாதிரி நிறைய கம்பெனிஸ் வந்துட்டாங்க. Next slide. So these are some applications. More than seeing the upon, you can see what is happening here. Some journals are just collected to give the breakthroughs. The computational methods vital for dereplication and creation of high quality. Lot of libraries are framed. It is having very good unique compound selection, increased chemical diversity, higher drug discovery, technology advance, process complexity. Learning about the read pannunga. Next, recent findings. Some authors, just I am showing here how they formed this AI algorithm, very with much accuracy of 95%, and the impact pathina efficiency of the drug, it increases. Next, Lee et al. Analyze NMR spectral data, accuracy of compound compared to manual interpretation. ரொம்ப நான் சொன்னேன் உங்களுக்கு, என்னமா கிட்டத்தட்ட அந்த மாலிகுலர் சின்ன சின்ன ஹைட்ரோஜன் கார்பன் சின்ன டிஃபரன்ஸ் கூட இட் வில் ஷோ ப்ரிசைஸ்லி. And lot of super computers, we have lot of high resolution instruments, analytical instruments. And the impact is what? Reliance on expert knowledge for analysis and access to dereplication. My topic is dereplication, so I am saying that. Next. So integration of multi-omics data. Omics and multi-omics and basic நம்ம படிச்சிட்டோம். So genome, protein, metabolic எல்லாம் டேட்டாவை எடுத்து சொன்னதை பற்றி அவர் ஜஹா எட்டல்னு ஒருத்தர் கொடுத்துருக்காரு. Offers a more comprehensive understanding of biological activities with therapeutic application of phytochemicals. Next. So இது research by Gupta என்ன சொல்லியிருக்காருன்னா, efficiently curate and maintain large libraries of natural products கொடுத்துருக்காரு. So for that you can access and usability for researchers, it is making more easy. Next. So general synergistic effects நான் ஒன்று சொன்னேன், new combination therapy, அதை பற்றி he has given the journal. So it also gives more effective therapeutic strategies. Next. So now whatever you are saying, I told you a lot of data, lot of statistics, lot of probabilities involved. Okay, these are all not facts. It is nearer value only. These are all not absolute. So definitely human intervention will be there. Can understand, because here what I mentioned, the data quality is what? Highly dependent on quality and size. Second thing, interpretability. It is very challenging. Without masters, without experts, it's not going to happen. Integration with traditional methods. Traditional methods சொல்லலாம். One small thing I will say, when I was in industry, okay, we have already made some products, and the product was in go down. Within 2 months, when we checked the product, I say one liniment, நம்ம தைல மாதிரி ஒன்று, அதில் பாதி காணும். அந்த பாதி காணும்னு சொல்றதால நாங்கள் ஆயமாவெல்லாம் சந்தேகப்பட்டோம். அங்கே இருக்கிறவங்களாம் கேட்டோம், யாராவது எடுத்து ஊதின்னு போயிட்டாங்களா அப்படின்னு. Then after some studies we found out there was slightly sediments was there, stability. நம்ம சொல்லிக் stability சிம்பிளாக சொல்லிடலாம். In natural product it is not easy. It is not easy to make stability. You can understand, after some time we found out crystals forming, sediment is forming. From the containers some oils are going out. See, most of the old preparations, the preparations are liquid preparations, even now also in herbal when you do in practically in industry, you will face that one thing like sedimentation will happen. Most of the tannins content will convert into flavonoids. And whatever inorganic substance like Fe, Mg, that will act like a catalyst. Sometimes it will improve the stability. Some inorganic will be showing the maximum stability. That will be making this particular samples not to sediment. So like that, a lot of studies should be done. இது ஏன் சொன்ன அப்படின்னா ரொம்ப சிம்பிளாக இருக்கலாம், பட் இவ்வளோ விஷயத்த நம்ம ஏஐயில் பண்ணோம்னா வித்தவுட் ஹவு ரிசர்ச்சர்ஸ் ஆர் காக்னிசியோ இல்லை கெமிஸ்ட்ரியோ எல்லாம் இல்லாமல் பண்ண முடியாது. இதுக்கு தான் நாங்கள் அடிக்கடி சொல்லுவோம், எவ்ரிபடி ஸ்டடி மெடிசனல் கெமிஸ்ட்ரி, எவ்ரிபடி ஸ்டடி ஸ்டூட்டிக்ஸ், ஸ்டடி engineering, என்னென்னா பண்ணுங்க. Then use this toy called AI. Okay, so this is the basic thing. Next, future directions. முன்னாடி ஒரு ஸ்லைட் இருக்குங்க இல்லையா, அதானா? Okay, AI specialists, chemists, biologists, everybody, they should realize first of all the potential of AI. இப்போ என்னுடைய பையன் ஸ்கூல் புக்கில் 9வது AI சப்ஜெக்ட் போட்டாங்க. அந்த மாதிரி we have to learn the tools. Ensuring ethical application. See, ethical application is not easy. ரொம்ப சிம்பிளான வேர்டில் சொல்ல பாருங்க, piracy and privacy. இப்போ எல்லாமே நான் எல்லாம் ஃபீட் பண்ணி விட்டேன்னா பைரசியாக இருக்காது, ப்ரைவசியாக இருக்காது. அது ரொம்ப கஷ்டம். There are a lot of ethical regulations are there. Misdiagnosis may happen. How the clinical trial can be done in a virtual screening. Whether that is enough? Our molecule we are doing 10 years. 10 years of work. 10,000 molecule, ஒரு molecule தான் வெளியே வரும் டைனாமிக்லாம் ஸ்டடி பண்ணி. Okay, so mistreatment, judgment, fairness. Can understand everything accuracy in the ethical regulation is very, very, very difficult. Definitely their experts are going to work. Definitely it will improve, there is no doubt. It will have disadvantage also, there is no doubt. And in that both, like mobile VR also will be surviving, don't worry. Okay, here, such as robotics, big data analytics, engineering technology, new dimensions, everything is going to come in the future direction. Next. And the conclusion is that significantly enhancing efficiency for de-replication process, that is my topic. And as I told, groundbreaking treatments for various diseases, specifically like precision medicine, reduces the time and resources. எல்லாத்தோட முக்கியமாக நிறைய வாட்டி சொல்லிட்டேன், நம்ம என்னத்துக்கான் டு ரெடியூஸ் த டைம். ஸோ இப்படிலாம் ரெடியூஸ் பண்ணோம்னா மேனேஜ்மெண்ட் என்ன பண்ணோம்னா, ஒரு ஆளை வச்சுட்டு 5 வேலை வாங்கிறதுக்கு 2 ஆளை வச்சுட்டு 25 வேலை வாங்கலாம்னு சொல்லிட்டு மக்களை போடுவாங்க. பிகாஸ் PI is more in India, population of India. Definitely it will help you for AI to survive and work. Don't worry. Next. So thank you. Okay. இப்போ நாங்கள் ரிசர்ச் இன்ஸ்டியூட் இருக்கும்போது ஒரு சிம்பிளான ஒரு இதுதான், ஒரு பாக்ஸ் வந்தது, சாய்மிடா செம்பர வைரஸ்ன்னு சொல்லிட்டு. ஓகே, இந்த சாலிடாகோ சாய்மிடா ஃபெப்ரிஃபிக் அண்டர் வேரசிட்டி சாலிடாகோ செம்பர வைரஸ்னு வந்தது. அது ஏற்கனவே நாங்கள் கேப்டன் ஸ்ரீனிவாசா ரிசர்ச் இன்ஸ்டியூட் ஃபுல் டைம் ரிசர்ச் ஸ்காலராக இருந்தேன். தட் இஸ் வெல் நோன் ஆயுர்வேதிக் ரிசர்ச் இன்ஸ்டியூட். ஓகே, ஐ வாஸ் இன் ஆயுர்வேதிக் ரிசர்ச் டிபார்ட்மெண்ட் ஸ்டாண்டர்டைசேஷன் ஃபார் 5 years. ஓகே, ஸோ அங்கே இருக்கும்போதுன்னா ஒரு சின்ன விஷயம் தான் சொல்கிறேன். இது அது வந்து நம்ம எடுத்து ஏற்கனவே ராயல் என்ற ஒரு ஆன்டி கேன்சர் காம்பவுண்ட் இருக்குது, அதை நாங்கள் வழக்கம் போல் ஐசோலேட் பண்ணோம், நோன் தானேன்னு சொல்லிட்டு. ஆனால் அதில் இல்லை அது மாதிரி கெமிக்கலு. அதை நம்ம வந்து 2 முன்னாடி பண்ணி பார்த்தா இல்லை. இது என்ன இப்படி இல்லை நம்ம சொல்ல முடியாது, பிகாஸ் ஆல்ரெடி ஜேர்னலிஸ்ட் பப்ளிஷ்டு எங்கள் இன்ஸ்டியூட்லேயே 1970s போட்டது தான் அது. ஸோ ஒருத்தருக்கு 4 தடவை செக் பண்ணோம், 5 தடவை செக் பண்ணோம். பாட்டனி அங்கே பாட்னி ஆளுங்க இருப்பாங்க, மைக்ரோபயாலஜி ஆளுங்க இருப்பாங்க, கெமிஸ்ட்ரி ஆளுங்க இருப்பாங்க, ஃபார்மசி ஆளுங்க இருப்பாங்க. டிஸ்கஸ் பண்ணி அப்புறம் சின்னதாக டவுட் வந்தது. நம்ம காலேஜில் படித்தோமே, factors affecting cultivation மாதிரி factors affecting storage ஒரு விஷயம் இருக்குல்ல, அந்த factors affecting storage மாதிரி அவங்க எடுத்து அந்த டப்பாலேருந்து எடுத்து பார்த்தோம், அவங்க எடுத்து அந்த கோணி பையிலேருந்து எடுத்து பார்த்தோம், வேற ஏதாவது நாரில் கட்டது எடுத்து வந்தோம். கோணி பையில் இருக்கிற செடியில் ராயில் இருந்தது. Secondary metabolism is also defense mechanism, don't forget. It also microbial transformation product, don't forget. It also is an enzyme degradation product, don't forget. Metabolites நான் சொல்லிட்டேன். ஸோ இவ்வளோ ஒர்க் இருக்கும்போது how without expert this AI will survive? It is not possible. Can you understand? So everybody try to study more science. Can you understand? And the second thing about Ayurveda, I want to say, ஆயுத கான்செப்டே நான் சொன்ன மாதிரி ட்ரை தோஷா வச்சுட்டு பேலன்ஸில் அக்கௌண்ட் பிரகிருதி வர்றது தான்ப்பா, அதுதான் ட்ரக் அக்கௌண்ட் டு த கான்செப்ட். அந்த கான்செப்ட் இதெல்லாம் போட்டால் உத்தரமெல்லாம் வராது. பட் ஆல் தி phytochemistry tools, they are tools for standardization, they are tools for commercial selling. இவ்வளோ தான். கேன் அண்டர்ஸ்டாண்ட்? மோஸ்ட் ஆஃப் தி மாலிகூல்ஸ் phytochemical தான், பயாலஜி கிடையாதுன்னு சொல்கிறான். எதுக்குமே கிடையாது, அதுதான் ஆல் ட்ரக் டெலிவரி சிஸ்டம் கன்வெர்ட் பண்ணுறான். அதுக்கு ஏன் காசு வேஸ்ட் பண்ணோம்? அந்த மாலிகள் தான் ஒர்க்கிங் மெக்கானிசமாக இருந்ததுன்னா அப்பயே சித்தர் ஆயுர்வேதம் முடிச்சுட்டு இருப்பாங்களே, எதுக்கு அவ்வளோ லேபிள் கிளைம் போடணும்? ஸோ த டோட்டலி கான்செப்ட் இஸ் டிஃபரெண்ட். கான்செப்ட் உங்களுக்கு ஏற்கனவே சொன்னேன், இந்த மிலிட்ரி மாதிரிலாம் சொன்னேன். ஸோ தட் கான்செப்ட் டிஃபரன்ஸ். ஹியர் ஆஸ் அ ஃபார்மசி பீப்புள் we have to study our science and use the toy called AI. Thank you, Pa.
Thank you, sir. Now I request our chairperson to conclude the session. Please, sir.
It was a wonderful talk by Dr. Satyanathan, giving the basic insights about the AI. So AI was a Greek Latin for us till now. So it is the transformation of the pharma students from the lab to the machine. So still now we were on lab. So you have to transfer the lab data now to the AI, that is to the machine. So it gives a lot of cost-cutting methodology, and it speeds up your research. So everyone, irrespective of your specialization, we have to learn the AI. So AI is going to rule the globe as well as our pharma field. Thank you. Thank you, sir.
Thank you, sir. As a mark of our appreciation and deep respect, we would now like to honor our distinguished speaker with a shawl and memento. May I now invite Dr. V. Shivashankar to kindly do the memento to Dr. V. Satyanathan, Principal, Apollo College of Pharmacy. Please, sir. As a token of our deepest gratitude and respect, we now take a moment to honor our esteemed chairperson for this session. May I request Dr. G. Sumitra to kindly do the honor and present the shawl and memento to Dr. V. Shivashankar. Please, ma'am. We remain grateful for your contribution to this international conference. Thank you, Lord.
Now we move on to the next session. This session by Dr. Umarappan Lambaram, Assistant Professor, Department of Pharmacology and Toxicology, College of Pharmacy, King Khalid University, Saudi Arabia. His topic focused on harnessing pharmacogenomics for individualized treatment, advances, barriers and breakthroughs. To lead us through this session, I now invite Dr. Jambulingam, Associate Professor, Department of Pharmaceutical Analysis, to introduce the chairperson, Dr. S. Jayaraman, Principal, Kangem Institute of Pharmaceutical Sciences and Research, to the gatherings. Welcome, sir.
Warm good morning to all. It's my privilege and honor to read out the resume of today's chairperson, an esteemed academician and researcher with over 25 years of teaching and research experience in the field of pharmaceutical sciences. He currently serves as a professor and principal at Kangem Institute of Sciences and Research, affiliated with the Tamil Nadu Dr. MGR Medical University, Chennai. He completed his B Pharm from JKK Muniraja College of Pharmacy, his M Pharm from Birla Institute of Technology, Ranchi, and went to earn his PhD He has made substantial contribution to the development of formulation. He has 11 research in and he has actively participated in 13 academic conferences where he presented his research on the topic related to herbal formulation and phytochemical analysis. To his research publication, patent for one of his phytochemistry. His works continues to be an valuable assets to the pharmaceutical science. Pharmaceutical sciences. So with this few biodata of sirs, I like to invite him to introduce today's speaker. Thank you, sir.
Thank you, sir. Good morning to one and all gathered here. First of all, I am happy to be the part of this national conference event. I would like to thank Principal Dr. Sambat sir, ERODE College of Pharmacy for inviting me. Also, I thank to the organizing team for inviting for this wonderful session. Really amazing, sir. Our principals are continuously doing more activities. We are watching more things from sir. That is continuously doing more activities by means of conducting events, programs, and taking care of faculty welfare and all those things. And we are also learning from many things from principal sir. Sir, thank you for inviting me. Also, I thank to the management for their broad approach and for their valuable support to organizing such events. Because of their support and all those things, you are executing all the events and the functions and all those things. Also, I wish them also. Now, let us introduce our this session speaker, Dr. Kumarappan Chidambaram. Is a highly committed academician and researcher, having more than 17 years of experience in teaching, research, leadership in the field of pharmacology. Currently, he is working as an assistant professor at King Khalid University, Saudi Arabia. He obtained his PhD in pharmacology from Jadavpur University during 2008. And he did PG and UG in under Tamil Nadu Dr. MGR Medical University. Mr. Kumarappan Chidambaram primary research focus lies natural product pharmacology related to diabetes and cardiometabolic disorders. He contributed 18 funded research projects supported by national and international agencies in Saudi Arabia, Malaysia, and Oman. He published more than 130 index research publications, filed 16 patents, and then published 5 books chapters and more than 3,300 citations with an H index of 32. He has supervised multiple UG, PG, and doctoral research theses. He served as an external reviewer for over 25 PhD dissertations globally. A recipient of multiple awards, including National Doctoral Fellowship under AICT India, Silver Medal for Academic Excellence, and the Outstanding Patent Award from King Khalid University honored lecturer by Cardiff University in the UK. He is an active member of international professional scientists societies such as the ACCP, AASD, ISE and the Malaysian Diabetes Association. He continues to contribute and revive research in metabolic diseases. So it's a brief biography of Kumarappan Chidambaram sir. So let us, sir, start your session. We are eagerly waiting to watch your session. I hope the session will be very interesting and informative to you. So please come and start your session, sir. Thank you.
Shall we start? Oh, thanks so much, sir, for the nice introduction. Okay, I'm not a big person. Okay, all right. Before we start the session, I would like to give my thankful to Dr. Sambath sir and all the organizers who actually invited me to be here. All right, and all the participants who have been here for last 3 days, isn't it? This is the last day. I think you must be overwhelmed with the information, a lot of information, a lot of knowledge you will be heard, okay? So I'm not going to give you a lot of information, okay? I will try to make my presentation very concise so that you will learn something from my presentation. In the back side, can you silence please? Who sit in the back side? I need your attention maybe another 30 minutes, okay? I'm not going to take much time. Silence, please, all right? If you have any questions, we will have interaction at the last session. Last 5 to 10 minutes, we can make it more interactive. All right. Shall we start? Okay. So, before I start my session, let me have 5 minutes interaction with the students so that don't be worried, okay? Don't be worried. It looks like you're scared, okay? I'm not going to make you scared, okay? I want to make sure how much knowledge you have before you start the session, all right? Just, okay? Mike, okay? I asked few questions before we start session because I want to make sure that how much knowledge you have to understand this topic, okay? That's the idea, okay? I'm not here to threaten you or to make some exam or something like that, isn't it? Is that clear? Are you ready? Yes or no? All right. So, can you someone answer what is the pharmacogenomics? Pharmacogenomics. Pharmacogenomics. Can someone answer what is pharmacogenomics? Yeah, come on. I could see more than a lot number of students. Anybody can answer, okay? If you know. There's nothing right or wrong, okay? Just share your information, okay? Few questions. Any idea about pharmacogenomics? No one? Pharmacogenomics. Yes or no? Yeah, come on.
How a gene affect a body to the response of drug?
Very good, okay. All right, you got something, okay. Good. Awesome. Okay, what is pharmacogenetics? What is pharmacogenetics? What is pharmacogenetics? Any idea? Decide. Boys, come on. Pharmacogenetics. What is genetics? Study about the genes. You can see the term genetics, okay, gene, okay. Pharmaco means how the drug is going to influence the gene. This is very simple, understand? So the talk, maybe like 30 minutes, I'm going to talk about how the drug is going to interact with your DNA and what is going to happen. Is that clear? This is more applied in the field of clinical pharmacy or clinical pharmacology, okay? You don't find, okay? More in the applied if you are going to be a therapist or maybe like a dispenser or maybe going to work on the clinical pharmacy. It is very, very useful, okay? Try to learn something, okay? I hope that it is a little bit dry subject. I will try to give some simplest way. Shall we move on? Shall we move on? All right. Okay, thanks so much for your questions and answers. So let's move on to the topic. This is my agenda, all right? I'm going to talk about next 30 minutes. I will try to make it as simple as possible, okay? So these are the learning you're going to learn at the end of the presentation, okay? I will try to cover at the last, all right? I'm just going to give you some introduction about pharmacogenomics. What is the clinical significance, okay, importance, how we are going to apply in the pharmacy, okay, in the pharmaceutical science or maybe in the clinical, mainly in the clinical field, okay, or in the clinical research. In the clinical research, how we are going to, maybe you can become a clinical researcher later on after finishing Pharm D or B Pharm. You may need to work on this field, okay. Then, what is the advances going on, okay? Because we have been taught conventional subject, okay, like a natural product, pharmacology, like okay. We are moving to the new era of medicine treatment, okay. There's a new kind of treatment. How we can applications. I can show some case studies. We have some lot of problem in implementations, okay. We have a lot of problem in practicing this one, okay. We have a lot of some Western country they started already. They are doing very well, but up to the India, we are just beginning stage. We are not that much far away from the Western country, but we have very good progress. We have very good progress right now. And I can give you some example. What is a breakthrough? Breakthrough means how we are moving to this one. Example I can give you. And finally, you're going to take some message or some information that could be useful for your career. All right. Finally, we can have some question and answer. You can try to answer it. All right. So what do you see in the picture? What do you see in the picture? Can someone tell it? What is it? Yes, DNA. But apart from the DNA, what do you see in the picture? There is a DNA, but what is the difference? Yes? Very good. Very good answer, okay? Can you see everyone has a different DNA? Can you see, is there any DNA same in this picture? You don't find it because we are unique. Each one of us, we have different DNA. Okay, then how a single drug can fit to everyone? Is it possible? Let's say I take paracetamol, but we have different DNA. How it's going to work for everyone? How it's going to work for everyone? Can I ask another question? If you go to shop, you go to a dress shop, what do you see? You see the different size of your body size, okay? Medium, large, XL, triple XL. You have different size. You have choices. But in terms of drugs, you have very limited. Let's say we have one drug, you have to use the same drug for everyone. Is that true or is it good or bad? It's not good. Because my genetics is different, your genetics is different, okay? So everybody has a different response. This is why we are moving to the pharmacogenomics. Am I audible? Is it clear? Excuse me. Am I clear? Yeah, all right. All right. So this slide talk about all my presentation, okay? I can finish my presentation with these slides, okay? As you can see here, so basically what we are going to talk about, the genetic variants. These terms is very important, genetic variants and the drug response. So if I take any drug, how my DNA is going to respond with respect to the drugs. So for example, one person will say, it works for me very well, But another person say, these drugs, I don't feel any improvement. Say, I have headache, I taken the paracetamol. You say, I got relief from the headache. But other person say, no, my headache still is there. Someone say, so I have other problem, gastric problem, after taking this tablet. Why? Same drug, different response. This is called, the study about this is called pharmacogenomics. Understand? The difference between the pharmacogenomics and genetics, pharmacogenome, we do the whole interaction of the drugs with the genome. Understand? Genetic means, pharmacogenetic means single. We just want to study about the single gene, how it will interact with the tablet or medication. Whereas genome means what? Whole. Your whole DNA. Whole DNA, how it's going to interact. That's called pharmacogenomics. So pharmacogenetics is part of small division of pharmacogenomics. Understand? Pharmacogenetic is a small division. It's just a small division of the genome, because genome is whole body. Gene is only one particular gene. Okay, I want to study about one particular gene. The study is called pharmacogenetics. So you need to understand this difference first. All right. Look at the picture here. So only one drug. Look at the same drug. Look at the drug is the same, sir, but the different people. Different people, different effects. So one say, I got effect. I got cured after taking this medication. But next one say, no effect. Next one says, no effect. The third one say, adverse drug reaction. He say, oh, I have liver problem after taking this medication. Why? But same drug. It is because of the genetic variation. Because your sequence of the DNA is different. With me, you have different sarees having different sequence. Okay, you can't give the same drug to everyone. So this is what we are doing for maybe 100 years. But now it's a time to change it. We cannot continue this strategy anymore. We have to change the strategy of pharmacotherapy. We have to go as an individual treatment. We call it tailoring. How you take the dress, okay? How you choose a dress for you, okay? How you go to tailor to make the dress is very fit for you, okay? That's how you need to do it. Here we are going to do the tailoring with the drugs. We call tailoring therapy, okay? So this is what pharmacogenomics. But how we are moving? We are moving to the next one, okay? The changes is started already. Maybe after 10 years, you see in 2035, you will be doing genetic test and you will be taking the drugs based on your genes. No more conventional way of prescription. Understand? This is what going to happen in after 10 years. Be ready for them, okay? Now you see the different drug. Can you see here? This drug is good for this person. This drug is good for this person. So this for this. Different drug, different people. Understand? Not the same drug for same people. So no more of this concept anymore. We are moving, we are migrating, we are transforming into the new way of treatment, okay? Pharmacotherapy. So basically simple definition. So what is it? Right drug, right dose, right patients, okay? So we are going to use the technology to optimize the dose, to select the suitable drug for the right patients. So pharmacogenomics is going to helpful for you to choose the specific drug and the right dose, okay? If not, you'll be having adverse effect, okay? So it is going to be right patients. This is called pharmacogenomics. Make it sense or not? Yes. So we have a lot of variations. Why the genetic variations? Why the genetic variations? Because there are so many changes happening. Can you see here? What is called? This is your gene. We call it SNP. I think you know about SNP. Single nucleotide polymorphism. There is a one nucleotide change. This is your common one. What is the changes here? Can you see here? GC, but here changing.
Disconnected.
Sequence is changed, okay? That's how we are different. Okay? Why? There are so many changes happening in the DNA, okay? For example, deleter. One of the sequence deleter, maybe you got new sequence or a nucleotide insert. By its genetics. It's by nobody is doing, because it's genetics happening by genetics. maybe duplications. Maybe you have two nucleotide, same nucleotide, duplicates, okay? This all will cause, sometimes we say mutations. You know the term? Mutations, okay? So this is called mutation, okay? These all different kind of mutation, okay? And the inversion, okay, see, shifting, sorry. Can you see the shifting? But this is called duplication, same nucleotide, and this is insert, okay? So you got some new insert and deleted. Can you see this is the one you original, but can you see the missing one? The orange one is missing. Some but deleted from your gene, deleted from your genes. So that's the one, change the drug response. So I may have deletion, you may have insertion, someone have duplications, okay? This is how the drug, different response. You get why you get different response. So this is the fundamental of pharmacogenomics. So we can use the two methods. These are, don't go into very detail about methodology. You don't need to know, okay? When you are going to become a master students, you will learn all those things, understand? So try to understand very simple things. So these are the two methods we use to study this one. These are the two methods available to find out the variations. Let's say you can ask me, what is the methods available? Is there a method available to detect? Yes, we have two methods available to find out this kind of genetic variations, all right? And I think I have given the definitions. Basically, we are working for two approaches. This approach, pharmacogenomics, is going to helpful to improve the efficacy. The first one, that's most important, okay? We have problem with the efficacy. The second one is more about to reducing the toxicity. This is the two parallel things we want to do it. First thing, because someone is complaining, this drug is not working for me. We want to, as a pharmacist, we need to help them to improve the efficacy by using this pharmacogenomics approach. The second one, somebody is complaining about the adverse drug reactions. So we have to help him. You cannot ignore. So you have to find the drug so that the toxicity can be minimized as low as possible. So this is the whole idea of pharmacogenomics. So why it's happening? It can happen. Mutation can happen anywhere. So during the metabolisms. So I think you know about cytochrome enzymes, isn't it? A lot of cytochrome enzymes, CYP enzymes, and you have the receptor. So mutation may be in the receptor, mutation may be in the drug transporter. Okay, it is not just only in the enzyme. It can be any of the biological tissue, all right, or in the target. Like we said, we have different target. Okay, like for example, pharmacologically we have a lot of targets, specific target, enzyme target. That target has mutations. Okay, so this is a problem because one size is not going to fit for everyone. We have to customize. We have to personalize. The doctor explained very last slides how to develop some of the AI tools to precise medicines. We are using a lot of AI tools. Also, it's part of the pharmacogenomics, which is helping for this one. Okay, so which is called the goal, the problem. One size is not more. One drug is no more useful. Understand? We have to select the specific drugs, specific patients. Okay, and the approach we use, tailored approach, and optimize the clinical outcome. Currently, almost 80% of the drugs has the problem. So, for example, you have 100% in market. In the current market, 80% of the drugs has a problem. So, how much drug is going to be wasted? So, we cannot ignore all the drug, but we have to use the techniques to select the right drug. So, 20% of the drug having the problem with the genetics. So, impact to reduce the adverse reaction, improve the efficacy, and the last one, the cost. For example, now you are spending a lot of money to buy the cancer drugs, okay? You are giving a random prescription. You are giving a random prescription. The cost is very expensive. You are doing the trial and error method, isn't it? Let's say I'm a doctor, you come to me, I give one drug first. It doesn't work for you. Then I change the drug. After 6 months, I will find out, it's not improving your cancer. I change the drug. So it's a cost. I'm spending a lot of money for buying the medication. So by this way, you can, if you use the pharmacogenomic approach, you don't need to go for trial and error methods. Trial and error method. That's a failure, okay? So now you know exactly which drug is good for you because based on your genes. So the cost can be minimized. Are you following me? Are you following me? Okay, thank you so much. So it can happen anywhere, okay? So it's a long process, pharmacokinetic, dynamics, So mutation can happen at any stages. It is not only in pharmacokinetics, it can happen in the pharmacodynamic, okay, polymorphism. The term we use, what we do? We use the polymorphisms. Poly means different, you're different. You're different from the own person to one. Like I said, deletion, duplication, some defect. You have some defect. It's not defect, it's how you design. It's how you design. Your body has genes, okay? So we have to change the drug accordingly, choose the drug. So this is a lot of stages you need to take, okay? When you take the medication and when you reach the clinical effect, so the problem can happen anywhere. So we need to find out this one and using appropriate methodology to find the genetic variation and choose the drug. It's clear? Okay, this is about the role of cytochrome enzyme. I think which one has the more important role? CYP, 3A4 and 3A5, it's metabolizing almost 80% of the drug. Understand? When you take any drug, liver has this enzyme. Liver has the enzyme. Specific isoform, CYP 3A4. This is isoform is metabolizing 80% of your drugs. So if you have any problem with this enzyme, then you will be having variations. Either drug will not work or to be more toxic or less effective. It's clear? So this is what. Look at the picture here. So we have, let's say for example, we have so many patients like you, and we can divide the group basically based on the response, okay? Variability. So one group, drug is not effective and not harmful. I take medication, not effective, but it's also no toxic for me. Understand? The second group, drug is good for me, but not harmful. It is really good. This is what we want, isn't it? I take medication, I don't want to produce any adverse effect. So I want to be part of this group. I want to be part of this group, not this one, not this one. Drug effective, but it's here harmful. It's good for me, but it produces a lot of adverse effect. You should not be this part of the group. And the last one, drug not effective, but only harmful. No effect, only harmful. So which is good group? This is what, okay? We are going to use the pharmacogenomic approach to make everyone this group, to bring everyone to this group. It's clear? So why is the difference? Like you have problem here. So you have different group. One is called homozygote, the hetero, then homozygous recessive, okay? Maybe the genes, you got it from the parents, 2 genes. And we have so the enzyme may be in mutation. So maybe you may be extremely fast metabolizer. You take medication, your liver will do the fast metabolism. Maybe within half an hour, it completes the metabolisms. Okay? The next one, intermediate. The last one, very poor. I take medication, it takes maybe like 3 hours to metabolize. But finally, I don't have any efficacy. Okay? Very poor, or maybe too toxic. Maybe the drug will deposit, because most of the drug will be accumulated free concentration in the plasma, because it's not metabolized. So you have free drug in the plasma, which produce more adverse effect. But here, the drug metabolizes fast, maybe like a 90% metabolized, you have only 10% for the effect. So look at the picture here. Okay, first one, homozygous, 70% of the metabolisms. I mean, I take medication, the metabolism will be 70%. So effect will be how much remaining? 30%. Look at the concentration. Look at the concentration. I need only small concentration. I need only at the small dose, I can produce the effect, because the drug metabolized 70%. Okay, but look at the heterozygous. So this is called a wild one. Wild one is almost everybody same. Okay, wild type. We call wild. Okay, WT means wild. Wild type, where most of the people will fall in this group. Okay, second one, wild, and they have mutations. Okay, they have some problem. So what is happening? Only 35% of metabolisms. So look at they need high concentration. Maybe they need the 50%. But look at the effect, because they have two problem. They have problem in the metabolism mutation. They also have problem in the receptor. So there are two polymorphism. One in the metabolism, the second one. Look at the therapeutic effect. good therapeutic effect, less toxicity. Second one, good therapeutic effect, but some adverse effect. The second one. The last one, which one? What do you call it? Mutant. We call it mutant. I think you have seen a lot of movies. So we call them mutants, okay? Because they have some genetic mutation, okay? That makes the person, how much? Only 1% drug will be metabolized. So 99% of the drug will be free drug. So what is going to happen? Look at the toxicity. More than 80% is toxic. If I take this drug, if I'm the person, this group, if I take any drug, more toxic for me. More toxic. Because why? Because of the mutant. I am a mutant. I am a mutant because there is something wrong with my genes. So we call it mutant. So we call it MM. So here, what is a clinical outcome? Look at the clinical outcome. Efficacy is only 10%. Efficacy is only 10%. But look at the toxicity. How much? More than 80% toxic. Because of the metabolism, because of the genetic variations. Is it clear? This is another example I want to give you, okay? Again, there are different factors will influence, okay? Your genetics or external factor. The food you take, maybe the environment, okay? But most importantly, which one has the problem? Is genetic expressions, okay? Genetic expression, so the orange one has more effect, okay? External factor doesn't play much role, okay? That means what? Drug X, you have main problem with the drug X, okay? This one, genetic variation, maybe you have 50% of the response, but this is maybe 90%. This also expression of the enzyme. Maybe I take medication, there should be some enzyme. The enzyme is not expressed, not produced by the body. So then you have only 25% of the drug effect will happen, okay? This is the variation, so different factors, all right? So here the same one, I skip it one, okay? So like we can classify poor metabolized or intermediate extension. Okay, the same one, okay? You have the different genes, according to the genetic variation, the response will be changing. Sometimes if this is a single gene, this is a multiple genes. So accordingly, the response will vary. If you have multiple genes, I have one mutation, but you have 10 mutations, understand? Then it will be, the response will declining. So we try to optimize the dose, this range, like we call this a therapeutic index, same like it, okay? Patient B, we need high concentration. What will happen? Adverse effect. If you increase the concentration more than this one, adverse effect. If you less than this one, okay, it's not going to be effective. So the best one is what you call this range. So this is the best range of population. We can give the drug without adverse effect, with the efficacy. So why we need the PGX? The same thing I told you before, to reduce the adverse effects. And the current one, we are giving a lot of hospitalization, a lot of expensive. Then the cost, we are going to improve the efficacy. Okay, these are some of the applications. Okay, first one, to predict the dose, prevent the adverse reaction, then enable we can also help them pharmacogenomics-based drug development. Okay, you can make a new drug. The drug will be helpful, useful for many patients, not just only one person, okay? We call reverse, we are going by reverse pharmacology. Then new drug for new cancer, okay? Then improve the efficacy. These are some of the applications. So these are some of the known example that you will study in pharmacology, understand? It's already we have problem with these drugs. Okay, why problem? I give you an example. I think you know about, what is these drugs? What do you call it? Warfarin. Warfarin, you must be very careful in the hospital because you cannot simply give it. So now you have to do if somebody is having this gene problem, then what is going to happen? There is an increasing bleeding risk. So what do you need to do? You have to test the genetic test. We call it genetic test. You must go to when you go to the hospital will do the genetic test for these genes. If you have a problem, then warfarin is not good for you. Warfarin will increase the bleeding. So this is called, we are going to correct all the problem. Understand? So these are some of the drugs for the cardiovascular. Then we have some drugs for neurology drugs. These are the genes. These are the genes having problem. Okay? These are the genes having problem. These are the drug. So what is the clinical outcome? So if you take this one, CYP2C19, the drugs for, I think, depressions, understand? If you don't do the testing, and what is going to happen? You'll be having more adverse effects. So what is the point? What is the point here? You must test genetic test. You must do the gene test for this one. Let's say there is no problem with this one, then you can take the drug. If you have problem in your genes, then codeine is not good for you. You can't take the codeine. So then drugs, some cancer drugs also have problem. So like abacavir. I take one case study, abacavir. So these are the, some data, which drug has produced more adverse effect? Antimicrobial. Look at the incidence. Look at the incidence, okay? This is in India. Okay, how many adverse effect happening reporting every India? And look at the number of the patient with adverse effect every year. 2019 is last data. So increasing every time is increasing. And some are serious, okay? These are some of the serious one. This is the total adverse effect. This is some non-serious one, okay? And what are the example? Like zidovudine, okay? Antiretroviral is the most common drug having adverse reaction in India, okay? Look at the data. How much like 85, the frequency, the number of frequency. So 88 times happening in the year, okay, to the patients, okay? This is simple data about the adverse drugs reaction in India, okay? How many adverse drugs reaction? So I skip these slides, it's the same one, okay? Sometime your gut bacteria also. That's why we say nowadays, this is very popular topic. You have to have good GIT, microflora, the bacteria, good bacteria. If you have good bacteria, you will be having no problem with the drug metabolisms. Let's say if your microbiota in the GIT is disturbed, then you will be having a lot of clinical problem, okay? So basically we are going to identify the genes. We are going to identify the enzymes, the problem with what enzyme, because we have a lot of CYP enzyme, CYP2C, A, B, so many subtype, okay? And we are going to identify the crucial genes which help for metabolism actions. So we need to find out what is the genes. Okay, that's called pharmacogenomics, okay? We need to identify the genes. And also enzymes, it can be drugs or targets, okay? For example, these are some of the target enzymes. So you need to identify. Let's say if I have no mutation, then I can take any drug, no problem. Because if I have this mutation, then I cannot take the statin. If I take the statin, why people complain of the adverse effect? Let's say I give the statin to someone. What is the adverse effect of statin? What is the adverse effect of statin? Muscle pain. If I take the statin, you'll be having muscle pain, okay? So then what is as a pharmacist, what do you need to do the patients? As a pharmacist, you need to reduce the adverse effect. How? You need to do the genetic test for the patient. Tell the patient, go to the hospital and do the test for this gene. If they have mutation, then statin is not good for them. They cannot take the statin. You have to give the other drug for cholesterol. You cannot give these drugs. If you keep prescribing, the patient will keep complaining about the muscle pain, muscle damage will happen. So these are the general outcome, efficacy and adverse reaction, okay? And we can minimize the trial and error method of prescription. We don't need to prescribe a random prescription, no. We are not going to do any more trial and error prescription. We are going to be very specific, personalized, precise medicine, very precise. If I give this drug, it works. It's not like before. And help for optimizing dose, save the cost, and also help for the development of the drug development also. But most importantly, here is all about clinical. The patient is also very important. And this is a history. I'm just to bypass, maybe if you want to refer with the slides back, okay? How the pharmacogenomics developed, okay? You can read till later development, okay? And these are some of the tools normally we can use for doing the pharmacogenomics. You want to find out the genetic variation, we use a lot of tools, okay? Even the doctor told you big data, biobank, okay? Even the bioinformatics, AA, also going to be useful for analyzing the data, because we are going to handle the large number of patient data. As you do more patient, the best one, okay? Not with a small number of patients, okay? This is how you can ask me how we do this one, pharmacogenomics, okay? You take your DNA and do the library. You prepare the library like a polymerize then sequence, you do the sequencer. There is a machine sequencer, and it will give you the exact variations. You can give the different, like it is all computer smiles, like a doctor told you, okay? Different files, name, okay? Then you can find what is exactly genetic variations. Then go for the drug. These are the methods, okay? We have a lot of breakthrough. So many drugs have problem. So by helping, we can reduce we can help for dosing, we can reduce the hypertension reactions, we can also reduce the risk of bleeding, okay? If you don't do the genetic test, then either drug won't work, or more toxic, or not effective. Understand? These are the very common drugs. So I'm going to take an example of one drug, abacavir. Just give me a 5 to 10 minutes, okay? This is very important. This is what you need to learn, okay? As a pharmacist, you are going to learn. I take this case study to explain very simple, okay? So abacavir is the drug used for HIV. It is a part of NRTI, I mean nucleoside reverse transcriptase inhibitor. It's a drug used for HIV. So people are complaining when you prescribe abacavir, they found very severe allergy reaction in the body, okay? After giving abacavir, many patients, almost like 5 to 8, 10% of the people complain there is a severe hypersensitivity reactions. They could not identify. Doctor also don't know why this is happening. They could not identify. They said, finally they found it is because of the pharmacogenomics variations, genetic variations. So they found this HLA is something present. If you have this one in your body, in your genes, then it's going to be a adverse reactions, okay? I'm going to give you, this is the drug. Don't look at the picture, don't be scared about the picture, okay? This is how the drug you take in the liver, get metabolized, comes inside, and it's going to block the DNA synthesis of the virus, HIV virus, okay? The last step is how the mechanism, this is about but look at when the drug is metabolized in the host cell, this is the liver, this is the host cell, and when you take the drug, abacavir comes inside, it converts into different form, triphosphate form finally, and when your cell doing the metabolism, there is some small compound comes out from the drug molecule. It's called haptens. So this haptens makes allergy reaction to your body. Understand? So it is a part of the drug metabolism. So why? Because you have these mutations. If I have this mutation, or if you have mutation, okay, in your body, then what is going to happen? There will be severe hypersensitivity reactions. So what is the point I'm trying to say again and again? Before you prescribe abacavir to any HIV patients, the patient must be done for the genetic test. It's called HLA-B. The testing must be done. This is now the requirement. It is no anymore choice. No, it is a must. It is a must requirement. In the hospital, they must do the test. If not, what happened? The patient will be experiencing severe allergy reactions. Understand? It is already FDA approved. If you go to hospital, they must do the test, make sure the patient doesn't have this mutation. Then there won't be any severe allergy reaction. If you prescribe without testing, then it will be a very nasty reactions. All right? This is why it's happening. This is basically mechanism how it causes, okay? Can you see here? Severe reactions. So what is the recommendation by the FDA? What is the recommendation? See here? What is called the testing of the specific mutation must be done before prescribing, okay? So because almost 8% of the patients are having the severe hypertension reaction after the 6 weeks of treatment, okay? So this is one of the case study. Has been many case studies. This is just an example. Number of cases has been reported with allergy reaction. This is one of the cases happened in the Kenya, okay? The 40-year-old patient, okay, has severe allergy reactions, abacavir, because they didn't do the genetic test. They must have done before prescribing. Okay, the final conclusion. So what is it? In the hospital, before you give the genetic test, nowadays all the hospital have this test. Same like a blood test. Take the blood and do the sequencing, and they will do very fast, okay? And they will give the result, like how you do the lab test. Same like it. It may be like a one day or 2 day. And after confirmation, you decide As a pharmacist or doctor, you decide whether to give or not to give based on the results, positive or negative. So now you can see the FDA has given the warning. Now FDA has given the warning. See here, this is a warning. Black box warning is given, and it must do the testing. This you can find in the drug label. You will find in the drug label, without doing the test, you must be, the prescriber must do this one. And this is a clear instruction, warning. Can you see here? Black box warning. This is a warning by the FDA. You cannot prescribe this drug without testing this one, without testing these genes. Must be tested before. All right, so I can talk theoretically, but there is a lot of issues, problem in implementation. Okay, the first issue, we need to educate more and more the patients and clinicians, pharmacists. You have to have more educations. Okay, I mean, you need to understand the principle of the pharmacogenomics in the practice, and funding is a big issue. Especially, let's say if I want to do some genetic tests, the cost is very high, expensive. The insurance company should be ready to pay back for me. For example, if the test is 1 lakh, how can I afford for doing only one genetic test? Can everyone afford? It's not possible. So the cost is also very important. So again, it's one of the limitations. Okay, then you need to integrate in the clinical practice. The research must be integrated in the clinical practice. The evidence must be, you have to do a lot of clinical trials. Randomized trial must be done, and a lot of issues. But still we have some barrier. So you have to have good education, patient education, clinical education. A lot of training should be given to the doctors, and more training should be given to the pharmacist. Okay, how this should be done. And technologically integration, use all the electronic data, patient data in electronically, so the data can be easily accessible. Use the machine learning and the AI, artificial intelligence. Okay, point of care. Point of care means I go to hospital, it can be done immediately. Understand? You should not say come back after 1 month for the result. I want to take the drug to the test. Within it should be readily available, like an instant test. How we do nowadays, nowadays all the tests is very instant. Okay, should be very easily available in the hospital. So believe, or you have to believe that we are transforming. We are moving to the next way of pharmacotherapy. That means it's going to be a standard part of care, and it's going to be helpful. You have to believe yourself first. If you don't believe, it's not going to happen anymore. Okay, and you must have the interest in the pharmacogenomics. You have to move from the traditional approach. The last one, the process need to be. I mean, the thinking should be changed. These are the number of publications. You can see the steadily increasing in the personalized medicine. This is very strongly supports that we are moving to the new way of treatment. Okay, as you can see, the personalized medicine, pharmacogenomics, number of publication. In 1995, hardly 200 publication. Now you see the publication went very high. So more research is going on. But the most important, this slide about illegal issue. Okay, it is not easy to do any genetic test very easily. You can take my blood, it's fine, okay? But maintaining the confidentiality, because you are going to store my genetic information, understand? It's more ethical issues there. The data should not be leaked out, understand? I don't accept my gene information should be transferred to anyone. Will you accept? No, it's a unique one, okay? So there's a lot of legal issues there. Maintaining confidentiality. For example, you have to handle this data, because it's all about human data. You cannot simply store in the laptop or something, okay? You have to have very proper securing data, and because it's all about your genomics. It's all about your genetics. Anybody can hack the data and they can give to any company, understand? So, and fair access. Everybody, I mean, pharmacists can access the data, clinician can access the access should be very fair, and you have to have very clear protocol. Simply you cannot done it. There must be very clear protocol how the pharmacogenomics should be done, okay, before testing, and you must have the concern. Let's say I don't want to take the genetic test. You cannot force me. Let's say you prescribe me a drug. Now you are a doctor. You are telling me that you have to do the genetic test, because if not, the drug will not work for you. Toxic. This is a recommendation from the doctor, but it is up to me to accept or not. Understand? I have the right. So I have to give the consent first. If I am not ready, then this is not going to work full. Understand? So the patient concern very, very important. The last one, the government must have the law to protect the misuse of this information. Very strong laws, okay? Like US, they have the law. This is the law from the US. If somebody is misusing my data, I can file the case in the court, okay? So India should have more law, such kind of things, okay? So these are the more future things we are expecting. We are trying to shift from the new way of treatment, from the old one, integration, and we have to work as a team. Let's say, it's not like a pharmacist separately, no. Pharmacist to work with the doctor, doctor works with the company. So it's a collective effort, then only it is possible. So there's a lot of evidences happening. You can read some of the tests is available. Even India, it's started already. So DPT is doing some of the sequence already. They done almost 10,000 people sequence, okay? This is another CSR. They did almost over 80 genes has been done for the 200. But look at the number of patients, very less. I would recommend like 10 lakh people. More number of patient is good actually. And this is another study has been done by the Indian government. You see here, they identified 102 genes variations in the human Indian populations. Okay, this is one of the study done by the CSIR. It's really progress, very good progress. So a lot of companies doing right now. I just give you some example. This is one of the tests is available in even the Amazon available. You can buy the test. You can do if you want to do the your dietary change, weight management, sleep, and skin. Okay. For example, you say that I have good diet. I want to reduce my weight, but it's not happening for you. Why? Have you ever asked? You try to do some diet. You try to change your lifestyle, but the weight is not going to improve, or either is not going to lose or gain. Why? Because you have some variations. You need to find out the problem, genetic problem in your genes. Then you can choose the specific food. Okay, this food is not good for you. This fruit is not good for you. Like this. So how this is helping? So this is one of the tests is good for this kind of problem. Currently available in the Amazons. Okay, there are some companies selling. Okay, if you are really interested in you can buy the kit. And this also good. Another right medicine. Okay, you can do. This also for one company is giving for cancer. For cancer, you can test I say the drug is not good for you. You can you can do the testing, genetic test. You can find the right drug for you. Okay, it's mainly for cancer treatment. Okay, OncoRx Comprehensive. These are a lot of the other company. You can go to all the company, some hospital like Apollo Hospital also doing. Okay, you can go and do the genetic test. Let's say I want to find out my problem. I can go to Apollo Hospital and this is called Apollo Diagnostic. I can do the genetic test. I can find my right drug for me. You can do right now. Understand? There's a lot of progress you should know. You should be aware about all those things, okay? Not just doing the regular study and everything. Okay, so many companies are going. And every drug will come with the labeling. So once there is a problem with the drug, they will identify the gene, they will mention. So you can find list of drugs in the FDA website. You can go to FDA website, you can see all the drugs having problem with the genes. Is it clear? So FDA is given the label. Food Drug USCI is given the label. So these drugs, this is a problem. Like I shown you some example before. So more than 300 to 400 drugs they identified it's having problem with the genes. These drugs have problem with your genes. So it must be prescribed only with the genetic test. So I came to the last slides. Okay, thank you so much for your attention. So what is a take a message that before we leave this, before I conclude this session? First things, it's happening right now. It's not that we are not just talking and every conference or something. Okay, it's happening right now. It's already started. So many companies investing, so many products are available in the market. But we want more broader category like cardiovascular, cancer. We need more and more drugs, more and more disease, psychiatry. Okay, now we have very limited test for limited disease. But in future, maybe in 2035, you will have tests, very simple tests. You can take your blood, you can do simply yourself. You don't need to go to hospital. The kit will come like that. You take your blood and do the test, you can find the drug for you. So we want that kind of things, okay? So, and you have to have very guideline. Without guideline, you should not be doing, okay? Clear protocol, clear guidelines, because there is a lot of legal issues there. And, but still, there are some barrier is there. For example, cost, it's not, especially when you work in the genomics, expensive, very expensive, okay? So the company need to offer like insurance, like how we have medical insurance. Now the insurance company should come forward and offer some cost-effective things, education, okay? And the last one, it works only by multidisciplinary. So team, as a team, you must work. So future is promising. We have, because we have support of AA. It's going to be very much useful in future. We can use all the AI tools to make the test is instant, okay? Like instant test can be done, okay? So can we take the quick 5 minutes? You take a piece of paper who are really interested, okay? If you have some paper or pen, you try to answer the question. I will give you, after 1 minute, I will show the answers. So you can check with your questions, how you did, okay? Maybe you can start now. Read the question. You can try to find out if you know any answer. I will show you the answer, don't worry, okay? But you can try to do by yourself, okay? Can you take a piece of paper? I request all the students or participants, take a paper and try to mark your answer. You can work as a group. You can work as a group, okay? Not as a one person, work as a group. So I'll give 5 minutes, sir. 5 minutes feels done, sir. Once you finish, tell me, I will move to the next question. So this will be the last one. So I just want to see your understanding, how you understand the lecture, I mean this presentation, what's your knowledge, so you can try to find out the answer. Tell me once you finish, I will move on to the next slides, okay? Or you want to take some picture also, you can do later also, you can find the answers. Is it easy? Is it difficult? Yes, sir? Yeah, maybe you can try, somebody can try to give the answers, okay? I will make it a live one, okay? If anybody know the answers, you can tell it, okay? So I will be done in 2 minutes, okay? Once finished. Question number 1? Question number 1? Yeah, very good. Excellent. So I think you have good knowledge on the pharmacogenomics. Okay, because the question number 1, the option is B. So we call this a multi-drug resistance. So if this gene is mutated, your anti-cancer drug will not work for you. Is that clear? So your anti-cancer drug will not work for you. What is the second question? Yeah, it's very easy. Option A, because I give ACE inhibitor like captopril. Do you know about captopril, enalapril? When I gave the captopril drug for hypertension, people complained of the dry cough. Okay, this is a drug for hypertension. If I take this drug, I'll be having dry cough. Why? Because the patient is having some mutations. So what mutations? They have mutation on the bradykinin. If they have mutation on the bradykinin, then you'll be having cough. So maybe 5 people are taking the same drug, but 1 person complaining about the cough. Why? Because he has the mutations. All right, so the answer is A. Question number 3, mutation in cardiac potassium or sodium channel associated. What is the problem? Let me explain the questions. Yeah, 1 minute, sir. I mean, if there is a mutation in the cardiac channel, you know, there are a lot of channels in the cardiac channel, potassium, calcium in the heart, okay? If you have any mutation in the sodium or potassium channel, what disease you will be having? What are the option? B. I think you must be a doctor, maybe. Doctor or student? Master students. You see, he could able to answer the question very clearly. So that means if I have somebody having the mutation in the channel, you know, ion movement, like, you know, ion move, potassium, calcium, magnesium will move. If you have mutation in this channel in your heart membrane, then you will be having long QT syndrome. That means the heart will take a long time to beat. We call long QT syndrome. It's a type of arrhythmia. It's a type of cardiac arrhythmia. Okay, that means if I have this problem, I have cardiac problem, I have heart problem. So why? Because of the mutations. Okay, this is the last slide. Question number 4. So how patients classify the ultra metabolized? What is the criteria? So I told you 4 metabolizer: ultra, then fast, intermediate, slow. So basically, you see you take any patients here who is sitting here, they must fall in 4 categories. First one, ultra. Second one, fast. Third one, intermediate. Fourth one, slow. So you must be one of these criteria. So you need to find out which category you are. So accordingly, the drug should be given. So you can see which one is, what will happen if I am the ultra fast or if you are the ultra rapid. I mean, I take the drug, within 10 minutes, the drug metabolized completely. Ultra fast, 10 minutes or 5 minutes, all the drug metabolized very fast. So what is going to happen for me? Wait, sir. Because you are good in pharmacogenomics, okay, maybe. What about student sides? So if if you are the ultra rapid metabolizer, so what is the consequence? Can you read the 4 statement? Sorry. Yeah. Because why? Very good. See, because the drug metabolizes very faster. Understand? And it loses the efficacy. It loses the efficacy. It cannot your liver cannot do the metabolism very fast. It must do like a intermediate, like a slowly. Then only the drug will be converted into active form. If you do fast metabolism, the drug will lose the efficacy. So what is happened? There is no clinical outcome. There is no clinical outcome. So it's really good. So option C. Number 5, this we discussed just now as a case study, very easy, okay? Let's say, if I prescribe abacavir, so what is the consequences? Severe hypertension reactions because of this gene. Let's say if you don't have this gene, what is the problem? Let's say I don't have these genes. If somebody is taking this drug, will there be a hypertension reactions? No. Good. This is what, okay? Only for those who have problem. If you don't have problem, you are fine, you are good. Your genetic is good because you don't have mutations. Clear? You will come to the main category. The last one, what is these variations is associated with which drug? What needed to be done? Any idea? B. Increase sensitivity to warfarin necessitating lower dose. Very good. Because if you have this, if you have this genetic mutation, if you prescribe the warfarin, and they will be having more risk of bleeding will happen, adverse event, because of the mutation of the VQORC1. This is the variant linked with the warfarin. So the last message I want to tell you, before you do the warfarin, before you initiate the warfarin therapy, because it's a narrow therapeutic drug. Narrow therapeutic drug, before you initiate, you must do the test of this one. Make sure the patient doesn't have this variant. Okay? Then he is free from the bleeding. If not, there will be a severe bleeding will happen and the patient will die very quickly. It's clear? So this is how we are going to help the patient to minimize the adverse reaction, improve the efficiency. All right, so this is the answers. You can cross-verify later on. All right, thanks so much for your attention. Maybe I'm in right time, maybe. If you have any questions, the floor is open. You can answer the question right now. It's now time for question and answer. If you have any questions, you can ask me, okay? Yes. No, that's the main idea we are working. Maybe, because we are trying to find out exactly is there any variation or not, okay? We are, maybe the drug may be point to, very good question. So what the doctor is asking, you are saying that one particular variant, the drug may also bind to the another genes, has some affinity. It may have some impact. Okay, but as a overall, what we are trying to see, from the current scenario, we are trying to minimize as much as serious adverse reactions. Let's say, for example, abacavir having serious adverse reaction. But if you know this, the HLE, we can minimize the adverse reaction. So that is the main idea. Understand? Maybe there are some adverse effect happening due to some variations that is not able to identify, but it's not doesn't have the clinical outcome. It's not clinically important. Understand? Maybe like I can say some vomiting sensation. What I'm worried about, serious. We are more worried about serious adverse reaction. Look at the data, how many drugs having reported every year, how many patients? Yeah, very good question, sir. There may be possibility, but maybe we need to refine. Maybe we refine. So it depends on the tests, how affordable. If it is become very easily available test, so then most of the gene can be done by very fast. It depends on the how fast we are going to do the research as much as fast. So we have to make the kits affordable, most importantly. So everybody can buy the kit, everybody can do the hospital, need to go to hospital, the space for the availability. This is called point of care, where you are going to hospital, the hospital should have all the equipment, testing facility, everything. So that level we should come, but we are too far. India is too far. But Western country, they move very faster. Many countries in the hospital they have. You can do the test immediately and you can check whether you have variation or not. Then accordingly you can choose the drug. But in India, we just started. Maybe like more than 20 companies now doing, but we have very simple product. Not very advanced like cancer, psychiatry, we have. Yeah. Any other questions? Okay. Okay, thank you so much. You can ask the questions. I'm going to be out 3 weeks after some time.
I request the chairperson to conclude the session.
So really it's a fantastic session. Thank you for taking us to the world of pharmacogenomics. So you clearly, simply explained about all the basic things about pharmacogenomics. Really very nice, sir. Really our students, that is especially PharmD, pharmacy practice and pharmacology students, gain more about pharmacogenomics from your session. Finally, you concluded that by knowing pharmacogenomics, we can develop personalized medicine. Also, we can go for right medication for a right person. Thank you, sir. Thank you very much.
Thank you so much, sir, for sharing your knowledge so generously. I request our chairperson, Dr. Jayaraman, to honor resource person. Next, I would like to call Dr. M. Jambulingam to honor our chairperson, Dr. S. Jayaraman. Let's have a tea break. Kindly come back by 12:30 p.m.
hello, cheers.
Disconnected. Paired.
கண்கள் ஏதோ தேட கலவாட நெஞ்சம் தானே பாட பரந்தோட
அடி ஒவ்வொரு பொழுதும் ஓன அப்படி நான் ரசிச்சேன் உயிர் கொல்லுது ஓனப்பு கண்மணியே ஓ ஒரு 1000 வானவில்ல ஓம் பூவிழி காட்டுதடி அத சட்டுன்னு நீ மறைச்சா நான் என்ன செய்வேன் புள்ள
கண்கள் ஏதோ தேட கலவாட நெஞ்சம் தானே பாட பரந்தோட
Welcome back all. It's time to dive back into the next session of our conference. This session will be carried out by Dr. Vasudevan Mani Kumaraswamy, Professor, Department of Pharmacology and Toxicology, Qasim University, Kingdom of Saudi Arabia. On topic on bridging neuroscience and therapeutics, emerging trends in neuropharmacology. To introduce the chairperson of this session, Dr. M. Vengadeshan, Principal and Professor, JKKN College of Pharmacy. I would like to invite our Dr. D. Krishnakumar Sir, HOD, Department of Pharmacy Practice, ERODE College of Pharmacy. Please, sir.
Very good afternoon to one and all. It is it's my pleasure to invite Dr. Vengadeshan Sir. Dr. Vengadeshan Sir is a seasoned pharmaceutical professional with over 20 years of experience in academia, research and consultancy. He holds a PhD in medical chemistry from the University of Queensland, Australia, with a scholarship worth 250,000 Australian dollar. He also earned a master's pharmaceutical chemistry and a bachelor in pharmacy from Indian universities. His expertise spans pharmaceutical chemistry, pharmacokinetic, pharmacodynamic, IVIVC, and analytical and bioanalytical method development. Dr. Vengadeshan is noted for his work on anti-Alzheimer's drug design, plant and marine bioactive compounds, and API quantification methods. He has held various academic leadership roles, including principal and professor, and he has contributed to facilitating training, faculty training, curriculum development, and institutional reforms. He has served as an examiner and regulatory advisor for pharmacy councils and universities. With 8 research papers, 5 international and 3 national publications, his research focuses on Alzheimer's, cancer therapy, and natural product drug discovery. He has received several grants and presented findings at major conferences, including American Chemical Society meetings. Dr. Vengadeshan is a member of multiple professional bodies. His achievements include the Best Paper Award in IPC 2010 and travel grants for international presentations. His multidisciplinary contributions continue to inspire professionals and students in the pharmaceutical industry and academia. With a brief introduction, we welcome you, sir. Thank you.
Disconnected.
Very good afternoon all. So it's my great pleasure
Paired.
being here. A wonderful knowledge sharing platform.
Disconnected.
And I'm really thankful to the principal, ERODE College of Pharmacy, the management and the team of organizing teams. So I thank for inviting me for this platform. Actually, I used to talk with my friends and think in Tamil Nadu, ERODE College of Pharmacy is #1 knowledge sharing platform. If I'm not mistaken, okay, correct me if I'm wrong, based on my observation past 5 to 6 years, ECP is a #1 knowledge sharing platform. I use this word knowledge sharing platform that includes conference, seminars, webinars, workshops. I really am also jealous, when we studied, we don't have this kind of opportunities. Hardly one conference takes place in a year. That is called IPC. We have to go all the way several miles. But now you have enormous knowledge sharing. A simple example, when you don't know how to upload a file or how to use Instagram or how to use a Facebook, you really ask your friends, right? So it's a knowledge sharing. So it's a similar way. You have a very interesting platform. I think ECP will become a #1 knowledge sharing platform all over the India very soon. So I pray for that. I really thanks and appreciate. And let me continue to introduce our today's speakers. Dr. Vasudevan Mani Kumaraswamy sir. So actually sir's CV is quite length, but I try to summarize it in short. Okay, and he is an excellent pharmacologist, pharmaceutical person, a pharmacist, Indian pharmacist, who has more than 2 decades of experience in teaching, research, covering various countries that includes Malaysia, Saudi, India. And his papers, research papers, I just went through his papers, what are the areas. So he covers the whole body, start from the microbes to the entire organ systems, and more focus on the like neuroprotection, neurodegenerative disorders, which is the most invited area in the world, I mean especially in the Western world. So he has done a number of, and the H-index numbers is really like 30 plus, and publications in 3 digits, and a number of patents. So he's such experienced researchers coming all the way to share the knowledge is an excellent opportunity for everybody, you and me, for everyone. So with this short introductions, I welcome Dr. Vasudevan Mani Kumarasamy sir. Thank you, sir.
So good afternoon to everyone. Thank you so much, sir, for a great introduction about me. And also I want to thank to Dr. Sampath Kumar sir also for my sir. He taught me in JKK Nadaraja when I was in B.Pharm. So I want to... Okay, sir. So, okay, great. So today we are going to discuss about some knowledge about for the neuropharmacology. Okay. So I'm not going to talk much about for anything advanced research or anything. So I'm going to talk whatever you studied in your CNS pharmacology. Okay. So I can go for the first slide. Yeah. So what do you mean by neuropharmacology? What do you mean by neuropharmacology? So basically, it's okay? Sound? Okay. So basically neuropharmacology, so just you came from your tea break, so you got some energy from tea, yes or no? Maybe you tried for tea or coffee. So how you got little energy? You got some energy, na? Some excitations or whatever. So what is that? CNS stimulant. So maybe caffeine if you take for the coffee or whatever. So this is basically for the central nervous system activity. Okay. So neuropharmacology basically it is a branch of pharmacology. It focuses how the drug affect for the central nervous system. So how the study of how the drug influences for the nervous system function and also as well as for the behavior. So molecular level, how the drug it will be acting on the central nervous system, how they are changing the neuronal activities. How the behavioral changes will be happening with the drug. So again exploring how the drug affect for the neurotransmitter. So you know well, whenever we talk about for the central nervous system, the main thing is a neurotransmitter. So how most of the drug, I think most of the disorders or diseases, we are going to related to the central nervous system. So we are more focused about for the neurotransmitter changes, modulations. Okay. Again for the receptors. Again for the signaling, cell signaling. So many things it will be involved for the central nervous system activity. So and also the neuropharmacology, it will be help understanding the brain functions at molecular and also for the cellular level. Again it will be support the development of the new therapies for the neurological, again for the psychiatric disorders. So it involved for the both basic research and also for the clinical applications. Again the key for the rational drug design targeting specific brain pathways. Next slide. So basically when you look about for the neuropharmacology, so we can see for the two major divisions under here. So one is for the behavioral neuropharmacology. What do you mean by behavioral? Behavior means whatever your emotional, anxiety, psychological changes. Okay. So the behavioral neuropharmacology, it will be covered for the behaviors, emotional, and also for the cognition of the humans. Okay. So again, for example, we can see what we can see in the behavioral neuropharmacology explains effect for the antidepressant drugs and the improve the mood. So when you look about for the molecular neuropharmacology, so it will be focused on the drug interactions with the neuronal receptors, ion channels, and also for the enzymes, again neurotransmitter. I am going to explain everything in the later slides. So how the dopamine agonist affect for the Parkinson disease. Anyway, I am going to explain you. Okay, the next slide. Okay. So when you look about for the clinical applications, so actually many, just I want to hear, so different type of the disorders or diseases, it will become under here. So mental health disorders, you can see the depression, anxiety, schizophrenia, it is a psychological issues. Again for the neurodegenerative disease, so what do you mean by neurodegenerative disease? Any idea? Neurodegeneration. Neurodegeneration, what do you mean by neurodegeneration? Neurons, sir? Neurodegeneration. Yeah, it is affect for the neuronal activity. Maybe the neuron, it will go for the die. Okay, they are losing for some particular area, the neurons, it will be go for the die. So what will happen? So it will be, maybe it is affect in the hippocampus, so it will be affect for the memory. Okay, according to the different, again the dopamine neurons, it will be affect for the Parkinson disease. So many things it will be connected with the neurodegeneration. It is a progressive degenerative issues. So it will happen for the slowly, it will be happen from the many years. So again for the epilepsy, you know, well I think seizure disorders, pain management, anesthesia. Again for the substance use and addiction therapy. So this is also one of the important, I think we have to recover the patients from the abuses of the any substances, smoke and everything, whatever you can see. Again for the cognitive enhancement and also for the neuroprotection. Again for the sleep disorder. Many area we can see for the CNS pharmacology. So basically you can see the neuropharmacology, it is having for the many interdisciplinary field, it will be under here. So one is for the neuroscience. So what do you mean by neuroscience? So basically it's understanding how the brain and also for the nervous system functioning. So basically you can see for the studies the neurons, again for the brain, how the circuits will be there, again for the synaptic signaling. So the synapse will be, what do you mean by synapse? Synaptic things. So it will be connecting with one neuron to the another neuron. Finally it will be reaches to the effector cells. Okay. So it will be, and also it will be give the knowledge about the, how the drug acting, pharmacodynamic issues. You can see the receptors again for the, how they are acting on the ion channels, it will be differ. So again the pharmacology, so you can, it will be give for the understanding how the drug interact with the biological system. So it will give you the knowledge about the, how the drug it will be acting on the, our body system. So here it will be give the idea about for the drug receptor interaction and also for the dose effects. Again it will be helpful to determine the therapeutic window and also for the side effect profiling. So I think whenever we use the drug, we should know about the knowledge of the adverse effect. Again, what is the safety windows and everything, it should be known. So again, it will give for the biochemistry knowledge also. So it is, what is the biochemistry? So basically it will be for the exploring the molecular pathway and also for the cellular reactions. So biochemistry reactions, how it will be the biochemistry changes, it will be happening. So you can see in the, it will give the knowledge for the, how the enzymes, neurotransmitter, metabolism. Again for the second messenger. So I think the receptor, one type of the G protein coupled receptors and everything, or kinase receptor, whatever, what will happen, it will be activated. It can activate it for the some secondary messengers. Then it will be give you for the different type of the activities. Cellular responses, it will be happening after the secondary messengers. So again, the clinical, crucial for the drug designs for the molecular level. So biochemistry knowledge, it will be must to know about for the, you understand the drug activity in the molecular level. So again for the psychological and also for the psychiatry. So the connecting the brain functions with the behavior and also for the mental health. So I think the psychological studies is a cognitive and also for the emotional behaviors. So anxiety and everything, it will be come under here. Again the psychological schizophrenic and everything, it will be come under for the changes of the some psychiatric issues. So again you can see for the psychiatric applications, you can see depression, anxiety, again for the schizophrenic and also for the bipolar disorders. So many disorders, it will be come under for the psychiatric changes. So again, when you look about for the, so behavioral pharmacology, I already told you, behavioral neuropharmacology. So basically it will be give you the knowledge about how the drug influences behavior, mood and also for the cognitive function. So what do you mean by cognitive function? Any idea? The higher level functions we have, the human we have for the higher level function. So we are thinking, we are learning, we are the memory, and also we have for the problems solving skill. So these all are, it is come under for the cognitive skills. So again it will be give the idea about for the brain chemistry and also for the psychological outcome. So again it will be the key focus area we can see. So when you look about for the mood, so it will become under for the antidepressant. So what do you mean by depression? If you talk another 1 hour, you will get depression. So your lower mood and everything, okay? So they are isolated from the social and everything, yeah? You know well, I think, in the CNS pharmacology, you already studied. So basically what will happen, the mood, it will be changes here, that is for the antidepressant. So we have different type of classification of the drugs. Tricyclic antidepressant we have, again for SSRI. So what is SSRI? Selective serotonin reuptake inhibitors. So and also we have for many classifications we have. So again for the anxiety, so most probably we have many different type of classifications for the anti-anxiety acid drugs. So particularly I think benzodiazepine is a big classification. So we have other classification. Barbiturates we are not going to use it. I think there is an older drug. So why we are not using barbiturates? Not preferable. Why? Why? Very simple question I think. Why? So there is no proper selectivity in the CNS depression, you can see. Again, I think the CNS depression level, it will be, according to the increasing the dose, the depression level will go for the higher. So it will produce anesthetic, again for the, it will go for the patient will go for the coma and everything when the dose will be higher. So again, barbiturate, they have the many important issues is narrow therapeutic index. So we have many issues, so we are prepared for the benzodiazepine. Still we have some more good classifications also nowadays. So again the cognition, so many nootropic drugs we are using, especially for the donepezil. Any idea about donepezil? Cholinesterase inhibitors, acetylcholinesterase inhibitor. Anyway, I will explain you later. Again for the addiction, so we have for the dopaminergic agents, we have for the stimulants. So most probably the addiction, why we are using for the dopaminergic agent, any idea? Very simple I can tell. When you go for the, I think many drug addictions will be there. So simply for smoking. So what will happen in your brain? you are getting for the exudation. Those who are smoking, they used to get for the exudation. Why? So they are activating through the nicotinic receptor, then it will be increasing for the dopamine level. So you know, one of the neurotransmitter dopamine, it will give you for more pleasure, excitations and everything. So that's only they go for the smoking, they used to get for the exudation. Especially for the, you know, the nicotine, within 7 to 10 seconds it will be reaches to the brain. So that's only the smokers, they used to get for the, every buff they used to get for the some excitation. So why we needed for this type of therapy here? How to manage for the therapy? So you know, when the addiction will be there, so we have for the one is physical addictions will be there. Psychological addictions, okay, just for the psychological stimulations and everything. When the physical addiction, what will happen, you know? Physical addiction. What do you mean by physical addiction? So you know, our body system, it will have balanced for everywhere, especially CNS activity is balanced. So when the abuser, they go for again and again the same drug for abusing, so the drug concentration, it will be long time, it will be maintained in their blood circulation. So according to the, you know, the what the substance they present in the blood circulation, the balance will be adjusted. So when the addictive, so they suddenly they stop the medications, what will happen? The balance will be imbalanced. So we need to go for the therapy. We have to try to go for the same type of the same mechanism or same type of the agents for the one approaches this year. So you know, I think the nicotinic they have for the, you know, chewing gum and many things for the replacement therapies. So this is one type of the addiction therapy. It is very important for the dopaminergic agents and many. It is according to what they go for the addiction based on. So for example, they have the addict with the CNS depressant drugs like alcohol or whatever. So we have to give the therapy for the some benzodiazepines. So again for the sleep, so that is for the sedative. So we have many drugs. I think benzodiazepine we have. Again for the zolpidem, Z drugs, we have many things we have for the sedative actions. Okay. So what are the applications for the based on the behavioral neuropharmacology? So you can see the application. So psychiatric treatment, so psychological changes and everything. We can go for the mood improvement for the depression. So psychological issues we can go with it. You have, you know, the schizophrenia we have for the negative symptoms. Again for the positive symptoms, many we have. So we can go for the schizophrenic treatment according. Again for the addiction therapy and also for the I already told you relapse prevention and everything. What do you relapse prevention? Relapse, what do you mean by relapse? Relapse. So the guy, they used to smoke for many, they stop sometime, again they used to start. So that is a relapsing. You know, different. Again for the behavioral neuroscience research, again for the cognitive enhancement disorders like, you know, ADHD, you know, the children they used to have for the attention deficit and also for the hyperactive disorders. Again for the Alzheimer's disease. So anyone know about Alzheimer's disease? Very simple, you can tell. Alzheimer, so memory loss. They used to tell dementia and Alzheimer and everything, you know, I think. So memory loss. That is one of the neurodegenerative issues. Especially some particular area, the neuron, it go for the degeneration. So the neuronal activity, it go for the degenerative. So the memory power, it will be challengeable. So slowly they lose the, you know, the memory. Then finally, they cannot able to recognize their own, maybe children or close relatives also. So this is one of the challengeable disease. So until now we don't have any proper therapy for it. Just we can manage only. So again for the example antidepressant, so I gave you for the modulation of the serotonin level. So molecular neuropharmacology. So molecular level, how the neuropharmacology will be there. So molecular level means what? Molecular level. The cell, they have for receptors, you know, so they can modulate for the enzyme levels, maybe they can modify for the receptors activities, maybe they can act as an agonist or antagonist. Yes or no? So they can change for the secondary messengers. So you can see the examine how the drug interact with the receptors, ion channels, enzymes and the neurotransmitter system. So this is come under for the molecular neuropharmacology. Yeah? So you can see the receptor, you know well about receptor. What is the receptor? Basically it's a macroprotein. It is present on the cell membrane. So normally these are activated by the ligand molecules. Maybe it's a neurotransmitter or enzyme, whatever. So you can see the enzymes. What is the function of the enzymes? Enzyme. They are involved for the, they are acting as a catalyst in the chemical reactions. It can go for the metabolism and many things. So this is the enzyme again for the neurotransmitters. What do you mean by neurotransmitters? Basically this is a chemical messenger. They transmit the impulses from the one neuron to the another neuron. Finally it will be reaches to the affected cells. Okay. So in that particular level, how the drug they are acting on the, you know, how they are modifying for the receptors, how they are modifying for the enzymes, how they are modifying for the neurotransmitter. So you can approach us for the different therapy for the different type of the disorders. Yes or no? Okay. For example, for the ion channels, later I will again, you know, the ion channels, how the ion channels are modified, how we can target ion channels. What do you mean by ion channels? What is the need of ion channels in the membrane? Binding the drugs. Okay. So basically ion channels, so you know the ions, they cannot able to crosses for the membrane. Yes or no? Ion can crosses the membrane directly for diffusion, any diffusion mechanism? Yeah, because of the electrical charges it cannot be. This is the polar. So it will be, cannot be diffuses into the membrane. So we need it for the special system. We have sodium channel, we have potassium channel, calcium channel. Okay. For example, you know the calcium. So many, you know the neurodegeneration, it is linked with the calcium channel. NMDA and everything, glutamate. So they are activating for the some NMDA, AMPA receptors and everything. So what will happen? The calcium, it is having for the cytotoxic effect. So the over calcium, it will be entry into the neuron, so it will be destroy the neuronal cells. So we have some medications, we can block the entry of the calcium, so we can. So NMDA receptor antagonists like this, so memantine like this drugs, it will be useful for the Alzheimer treatment. So again for the some of the key focus area, so receptor binding and also for the signal transduction. So secondary messengers and how it will be affecting the cells. Again for the modulations of the ion channels, I already told, so many ion channels it will be focused in the central nervous system. I already told for one of the example for the calcium. Again, when you look about for the epilepsy. So most of the drugs, they are blocking for the sodium channel or calcium channels are. Again, they are activating for the GABA aminobutyric acid. So that is for the inhibitory neurotransmitter. So they can open for the chloride ion channel. So they are reducing the excitation of the neurons. They control for the epilepsy. Yes or no? You studied, I think. Yeah? So that is the modulation of the ion channels. Different ions we are focusing. So again for the enzyme inhibition or activation. I already told you for the Alzheimer, again for the dementia and Alzheimer. So we are increasing for the acetylcholine activity. So acetylcholine, you know, one of the major neurotransmitter. Yes or no? Acetylcholine. So acetylcholine, they have a lot of functions in the brain. So one of the functions, what will happen, it will be improved for the memory. So acetylcholine, what will happen, how it will be metabolized, you know, acetylcholine? You studied, I think, in the ANS, autonomic nervous system. Sir? Yeah, cholinergic drugs. So basically, acetylcholine, what will happen? It will be metabolized by the acetylcholine enzyme, choline enzymes, okay? Cholinesterase enzyme. So what will happen? We are developing the drug, we are inhibiting for the cholinesterase. So we are improving the level of the acetylcholine between the synapse between, synapse. So more cholinergic receptor will be activated. So again for the neurotransmitter synthesis, releases, and also for the reuptake. So particularly I want to tell about for the reuptake. Where we are using this one? The reuptake. Many reuptake inhibitors we are using. SSRI, yes. Tricyclic antidepressant. So they are targeting which enzyme, which neurotransmitter? Adrenaline. So especially for the tricyclic antidepressant. So what is the meaning of reuptake? First of all. So I put on where for the reuptake. So I already told you the acetylcholine, it is destroyed, it will be metabolized by the terminating the activity of the neurotransmitter. So once the neurotransmitter go and bind to the receptor, so it cannot be there in the long time, I think. It will be destroy the receptor. Yes or no? So it has to be removed. So that is a one mechanism for the acetylcholine is a cholinesterase. The same thing for the all monoamine neurotransmitters. So like, norepinephrine, serotonin, dopamine. So these all are the main mechanism of the terminating the activities of the reuptake mechanism. So they have the transporter in the presynaptic neuron. So they remove some amount of the neurotransmitter again into the presynaptic neurons. Again it will be destroyed by the enzyme or it will go to the vesicle, it will be stored it. So this is a normal activity in the monoamines. So when we block for the reuptake one, so we can increase the neurotransmitter level. I have one small picture, I will explain you again. Okay. So what are the applications when you look about for the molecular neuropharmacology? Just you can see. So it will be useful for the drug development, obviously, I think. So neurological and also for the psychiatric disorder. Again for the understanding of the side effects and also for the some target actions. Again for the advancing the personalized medicines and also for the targeted therapies. I gave you the examples how the dopamine agonist it can be helpful for the Parkinson disease. They are activating for the dopamine receptor, so they can useful for the Parkinson disease. So this one I am telling about for the neuroanatomical targets. So the different area of the brain they have for the different actions. They are different controls and everything. So you can see we can approaches for the different area. So easily we can try to give for the some medications for the disorders. So first for the basal ganglia. So you can see the basal ganglia, especially they are controlling for the motor activity. The movement and the muscle things and everything. Muscle contractions and everything, it will be controlled by the motor basal ganglia. So when we targeted for the basal ganglia, so we can improve for the motor activity and also for the habit of learning. So it will be useful for the some of the dopaminergic drugs like for the Parkinson disease. Next. So again for the limbic system. So limbic system it will be having for the amygdala, hippocampus and also for the hypothalamus. So particularly hippocampus it will be important for the memory and memory functions and everything. Okay. So they can center for the emotional memory and also for the reward system. So again for the affecting by the antidepressant drugs, anxiolytic drugs and also for the additive substances also we can. So the reward system means what will happen? So it will be related for the addiction. So again for the prefrontal cortex, particularly for the prefrontal cortex it will be more helpful for the working memory. So again, we can see the executive functions, again, decision making, and also for the impulse control. So it will be useful for the ADHD, so attention deficit hyperactive disorder, and also for the depression, and also for the schizophrenic issues. So cerebellum, I give some example for different area, how they are controlling for the different functions. So we can target for this particular area, so we can try to manage the issues. So again, cerebellum, they are involving for the coordination, balancing, and also for the cognitive timing. So it will be sensitive to, it will be go for the sedation, and also for the alcohol, it will be acting through here. Okay. So this is very simple. I am giving for the each, the neurotransmitter. So how it will be correlated for the different issues. So dopamine. So the dopamine, so where it is important? Antidepressant. No. Yes, sir. Dopamine. So especially you can see for the motivation, reward, and also for the motor function. Again, the muscular coordination, it will be controlled by the dopamine. So Parkinson, again for the psychiatric issues. Whenever you look about for the dopamine, basically for the CNS pharmacology, you have to think about these two things. So one is for the Parkinson, again for the schizophrenic, and also for the addiction. So most of the drug addiction based on the dopamine activity. Okay. So for example, levodopa. And for the different type of the anti-psychotic therapies you can see. So levodopa, where we are using? Combination of the levodopa and carbidopa. Can you remember? Parkinson disease. So one of my question, the dopamine can crosses for the blood-brain barrier? No. Great. So that's only we cannot give injection for the dopamine for the Parkinson disease. The levodopa we are giving. So we have the special transporter. It carry the levodopa to peripheral to the central nervous system. So we have the enzyme. It will be converted to the levodopa to the dopamine. So dopamine, it will go and bind to the specific receptor. They are activating the, the dopaminergic neurons, and also it control for the movement issues, muscular issues, muscular coordination and everything. So antipsychotic. So some of the theories, what they are telling, there is a overactivity of the dopamine, so it will be producing for the different type of the psychological issues. So we know that traditionally we are using many drugs, D2 receptor antagonist. Can you remember? Chlorbromazine and everything. So that is basically for the D2 receptor antagonist. So, and also they have a lot of adverse effect because we are blocking for the D2. So one way what will happen, it is producing lot of movement issues. When we blocking for the D2 receptor, okay, for the psychiatric therapy, so we have for the different type of the movement disorders, it will be there. Again, there is a changes in the prolactin level and many things. You can remember, I hope. Okay, so when you look about for the serotonin, they have a lot of activities, serotonin. So one is for the mood and also sleep and also for the appetite. So they are linking with the depression, anxiety, again for the obsessive compulsive disorders. So they used to do some repetitive things, obsessive compulsive disorders. Again, for example, SSRIs, fluoxetine. So this is one of the example. They are acting as a serotonin, selective serotonin reactive inhibitors. So again, GABA. So what is the function of GABA? It's one of the major inhibitory neurotransmitter present in the CNS, GABA. So what is the mechanism of the GABA? I have one slide to show you. What is the mechanism? There? No idea. Huh? Okay. We have different type of receptor GABA, I think GABA. Okay, anyway, I will explain to you. Don't worry. Okay, this is basically for the primary inhibitory neurotransmitter. Again, they are anxiety and also for the epilepsy. So normally the CNS excitation, it will be correlated with the anxiety as well as for the epilepsy. So GABA is an inhibitory neurotransmitter. So they open for the chloride ion channel. They used to control for the excitation. The chloride ion is a positive ion or negative ion? Negative ion. So they used to produce this for the hyperpolarization. Okay. So the examples I gave you for the benzodiazepine. So glutamate, yeah. So this is the one of the major excitatory neurotransmitter. So they are acting through the NMDA receptor and also for the AMPA receptor majorly. So actually the problem for the excessive glutamate activity, they can induce us for the neuronal degeneration or destroy neurons and everything. So they are correlating with a different type of the disease. So glutamate is a good one. So excitatory neurotransmitter and everything. But overactivation of the glutamate, so overactivation of the NMDA receptor, so what will happen? They allow more amount of the chloride into the cells. So when it will be the high level of the chloride ions, what will happen? It will be destroy the cells. So that's why we have memantine, the one of the medication we are using for the moderate to severe Alzheimer management, not treatment, management. Okay, so acetylcholine. Basically acetylcholine, they are involved for many type of the functions, learning, memory, cognitive things, again muscular activities, neuromuscular junctions also they are present in the acetylcholine. You can see for the Alzheimer disease and many diseases it will be correlated. So we have for examples donepezil, rivastigmine means, so they are cholinesterase inhibitors. So I gave you one simple table for you. So you can see the depression. So basically you can see the lower level of the serotonin, again lower level of the norepinephrine is correlated for the depression. Again when you look about for the Parkinson issues, so dopamine level it will go down in the, especially for the nigrostridyl pathway. So Alzheimer, so lower level of the acetylcholine. Again for the anxiety, so the GABA activity will be go low. So when we are improve the GABA activity, so it will be producing for the inhibitory effect, control for the emotional and everything. So schizophrenic psychological issues, so overactivity of the dopaminergic, especially for the mesolimbic pathway. Okay, so the receptor, I think you are very familiar about for the receptor targeting and everything. So we have 4 different type of receptor major classification I know. So I am going to give only for just 2. So they are major. So one is for the ionotropic receptor. So basically this is for the ligand gated ion channel. Ligand gated ion channel, so they are acting very fast, I think. They are also correlating for the different, the disorders it will be, approaches we can do it. Especially for the GABA A, so they are allowing for the influx of the chloride ion. So they are reducing for the inhibitory effect to the neurons. So this is one type of approaches we can see. Again for the NMDA antagonist we can tell. So it can control for the over excitation of the NMDA receptor. It can control for the calcium induced, the cell death and everything. Again for the second classification is a G protein coupled receptor. So normally what will happen, G protein coupled receptor, they are activating for the number of the secondary messengers. So they are altered for the different ions and messengers also. So the slower but longer last acting, so they are activating for the second messengers like cyclic AMP or IP3 or whatever. So the examples we can see serotonin 5-HT1A receptor, again dopamine D2 receptor, muscarinic acetylcholine receptor, they are the examples. I think you know well about it. Okay, so pharmacodynamic approaches we can see for the understanding. So pharmacodynamic means so mechanism. How the mechanism approaches based on the CNS activity we can see. So one is for the receptor binding and also for the selectivity. So you know well I think the drug, it will be bind to the specific receptor. What do you mean by specific receptor? The drug bind to the specific receptor. What do you mean? Acetylcholine, it will be go and bind to the only acetylcholine receptor, maybe muscarinic receptor or nicotinic receptor. It cannot go and bind to the alpha 1 receptor, beta 1 receptor, adrenergic receptor, never. So it is very specific. Okay. So again, the selectivity also, it is so targeting of the particular pathway of the fewer side effect. The selectivity is very important. So when we develop the drug very selective to the specific receptor, so we can avoid for the many adverse effects. You got it? What do you mean? So for example, we are developing some drugs for the asthma. So what is the main approaches? We are activating the beta 2 receptor. So when it will be bind to the beta 1 receptor, what will happen? There is a lot of cardiac side effects. Yes or no? So how the selectivity, the drug to the beta 2, it is a better. But still the higher doses, it can be interact with the beta 1 receptor also. So this is the selectivity. Sir? Yeah. Okay. So that's what I am telling. So which drug is more specific to the specific receptor, it will be more chances to lower the side effect. But anyway, higher doses, there is a chances. Okay. So this is the example I gave you, SSRI. So they are only active through the serotonin transporters. It will never be disturbed for the dopamine other transporters. So because all are monoamine structures. Okay. So when you look about for the pharmacodynamic, so we have agonist, antagonist, and also for the allosteric modulator. So you know familiar about agonist, antagonist? Yes or no? Agonist means they are activate the receptor. So antagonist, they used to block the receptor. What is the allosteric modulator? How you differentiate agonist and allosteric modulators? Any idea? So basically when you look about for the allosteric modulator, they bind in the non-active site of the receptor. Again, they are enhancing or inhibiting the receptor responses without directly activating it. So for example, benzodiazepine. So how it will be happen? I gave simply for one example benzodiazepine. I am telling the drug it will be acting through the different way. They are activating the the receptors and everything. How? So next slide. So this is the one picture I think you can see in the. So how it will be differ? So benzodiazepine we are telling they are activating for the GABA. Yes sir? Yes or no? How? It is allosteric modulated to the GABA A receptor. So how? So when you look about here, the GABA binding site is different. You can see this is the GABA binding site. The benzodiazepine never bind here. You know well, I think. It is having for the different binding site. They are just increasing the activity of the GABA. They are. You got it or not? So they only benzodiazepine they cannot activate the GABA A receptor. So just they are increasing the activity of the. They are increasing the activity of the GABA. So when the benzodiazepine is needed, the GABA should be active. You got it or not? So benzodiazepine GABA it will be bind here. It is between for the alpha and beta. So when you look about for the benzodiazepine, they have for the alpha and alpha and GABA interface they have for the binding site. So the benzodiazepine, the GABA it will be bind to the alpha and beta, that particular binding site of the GABA. But benzodiazepine it will be bind for the benzodiazepine binding site. So just they are increasing the activity, they are enhancing the activity of the GABA. So when you look about for the, normally they used to open for the chloride ion channel. So when the benzodiazepine it will be bind to the GABA A receptor, just they are increasing the frequency of the ion channel. I think you know better. So when you look about for the barbiturates, so they used to prolong to open for the chloride ion channel. You studied, I think, hopefully. Yes? Okay. Yes? Can you remember or not? So this is the allosteric modulators. So it never be bind to the same binding site of the GABA. Just they are increasing, enhancing the activity of the GABA. Either way, I think benzodiazepine, they are increasing the frequency of the chloride ion channel opening. So when you look about for the barbiturate, they are prolong the opening of the chloride ion channel. Okay, I already promised you, I think, some antidepressant, reuptake and everything I will explain to you again. So, basically for the depression, so the long time there is a lacking of the monoamine neurotransmitter, specifically for the norepinephrine, again for the majorly for the serotonin. Okay, so when the long time there is a lacking of the neurotransmitter, so what will happen? The receptors, it will go for the upregulations. You know, I think. So the receptors, it will go for the upregulations. Just you can see this is the serotonic neuron. So you can see this is a free synaptic neuron. Free synaptic neuron. This is for the postsynaptic neuron. So what will happen? We have some autoreceptors. What do you mean by autoreceptor? You know, autoreceptor and autoreceptor. You know, alpha 2 receptor in the norepinephrine. That is an autoreceptor. What do you mean by autoreceptor? So they are present in the free synaptic neuron. They used to reduce the releases of the specific neurotransmitter. Can you remember? Autoreceptors, heteroreceptors. So you can see the serotonin. So 5-HT1A receptor is a autoreceptor. So they used to go for the upregulations. So first things you know, I think when the depression therapy, antidepressant drugs, so when it will be go for the onset of action, when they start the medication, you know, immediately they cannot get for the improvement of the mood changes. So minimum, I think few weeks they have to take the medication. So then only it will be start to improve the mood. Why, you know? You know, any idea? So depression therapy. So immediately 1 or 2 days you will not get any activity. There is no changes of the mood or whatever. Okay? So they have to continue for at least 2 to 3 weeks more, then the onset of the mood changes will be starting. So why? So this is the reason. So when the long time they have the lacking of the serotonin, so the 5-HT1A receptor and 5-HT2A receptors, they used to increases the upregulation of the receptors. So especially for the 5-HT1A receptor, they are acting as a free synaptic autoreceptor. So what is the function here? So the receptor, it will be reducing the releases of the serotonin here. Okay? What is the function of the autoreceptor? So it will be reducing the releases of the neurotransmitter in the synapse. So again it will go for the upregulations. What will happen? Again and again it will be reducing the releases of the neurotransmitter in the synapse. So when the patients will start the medication, so what will happen? They used to block for the reuptake, okay, transporter. So first they will increase the neurotransmitter in the synapse. So slowly they increases the neurotransmitter. So what will happen? It will be correct the number of the receptors. Whatever the the high number of the receptors, it will be controlled first. So then it will be regularized is the normal number of the receptors. So what will happen? Then they continue the medications there. First it will be correct for the whatever the abnormal number of the receptors, autoreceptors here. So first they are increasing the more neurotransmitter in the releasing. So the patients it will have for the some mood improvement. So that's only the onset of actions will be taking for the 2 to 3 weeks more, I think, nearly month, I think. So this is the issues in the antidepressant therapy. So what do you mean by uptake blocking? So this is the transporter. So what will happen? It will be some amount of the neurotransmitter, it will be reuptake into the free synaptic neuron. So it will be go for the storage or maybe some enzyme it will be destroyed. So this is the one of the way it will be terminate for the activity of the neurotransmitter here. So when we block it, so more amount of the neurotransmitter they are present in the synapse. So it will be correct for the whatever it will be recorrect for the upregulation of the receptors here. So again it will be allowed to improve more neurotransmitter it will be releases. So the mood it will be start for the improvement. So this is the one of the issues when we go for the antidepressant therapy. Next. So still we are in the pharmacokinetic approaches for the CNS. So particularly you can see the when you look about for the target for the drugs in the CNS, so important is the route of administration. So according to the changes of the route of administration, it will be changes how the drug it will be reaches to the CNS. So main things blood-brain barrier. So high lipid soluble drugs it can be crosses for the blood-brain barrier. So it is very important for the improve the lipid solubility. Then only that particular drug it can be reaches to the central nervous system. Again for the distribution, you know well I think high perfused organs it will be the drug it will be reaches very fast, but still blood-brain barrier is challengeable to reach the drug to the brain. So we need it for the high lipid soluble drugs. And next slide. So metabolism, so you know well I think, so some of the prodrugs I think we are using for the some of the therapy. So you know about the prodrugs. What do you mean by prodrugs? So these are inactive form. So when it will be enter into the enzymes, so it will be converted to the active form. So one of the great example is levodopa. So normally we are taking levodopa in the peripheral. It will be reaches in the blood circulation. When it will be crosses for the blood-brain barrier through the transporter, so it will be converted to the dopamine. Okay. So excretion, you know, I think, so we have for the kidney and bile system, it will be go for the major excretion. So it has to take knowledge about how the drug it will be excreted. So again for the first pass metabolism, so you know, I think inactive before reaching to the systemic circulation. So it is a very important when the drug it will be taken by the oral. So again the blood-brain barrier, I already told you. Again for the half-life, again for the CNS bioavailability. These things we have to concern about for the CNS drugs. So how the drug design strategy it will be improved for the crosses for the blood-brain barrier. So one is for the increasing for the lipid solubility. I already told you the high lipid soluble drugs it can be possible to crosses for the blood-brain barrier. Another important thing is size of the molecule. That also very important for the concern about for the blood-brain barrier. So we have for the prodrug, I already told you. So prodrug it will be reaches to the brain, especially for the levodopa for the Parkinson. So it will be converted to the dopamine, so they can improve the Parkinson issues. So again, we can make some nano carrier delivery system, so we can improve for the drugs process for the blood-brain barrier. I already told you the size of the particles also very important to concern. Okay. So especially for example, I gave you one of the drug doxorubicin, so anti-cancer drug. So it will be very helpful for the brain tumor therapy. So when you go for the nanocarrier delivery system, we use just simple example for you. Okay, we have another approaches for the receptor mediated transport. So we can link the drug to the different the ligands like transferrin. So what is the function of the transferrin? Any idea? They carry ions. Yes or no? In the body system, they used to carry for the ferric ions, I think. So it will be reaches. So this is one of the carrier molecule. So the transferrin or insulin, we can conjugate with the drug, so they can help you to crosses for the blood-brain barrier. So it will be one of the, I think some of the drugs, monoclonal antibodies. So basically monoclonal antibodies they are having for the macro structure. So they used to attach with this type of the ligands. So it will be helpful to process for the blood-brain barrier through the transporter or specific system. So it can reach us to the brain. So when you look about for the efflux pump inhibitor, I think you know B-glycoprotein. Just now Dr. Kumarappan told you, efflux pump. So that for improve for the multi-drug resistance. So when we use some inhibitors, so maybe we can improve the drug they are present in the brain, okay? So some of the proteins they found recently, I think they can target for this particular proteins they are present in the pre-synaptic or post-synaptic neurons. When we improve this type of the proteins, they can increases for the activity of the neuron. So one is for the neuroxins that is mainly present in the pre-synaptic neuron. So second is for the neuralgin. So they are present in the postsynaptic neurons. So this type of the protein, they have linked with many activity of the neurons. So it will be, when we target the drug to improve this type of the proteins, so maybe we can improve the functions of the brain. Next. Again, another issues you can see approaches. So astrocytes and also for the gliotransmission. So I think astrocytes, they are supporting for the neuroglial cells. They are supporting for the neuronal function. So we can, the other way you can see for the releases for the chemicals, they called gliotransmitters like ATP or D-serines. So they are also helpful to control for the, signal strengthen again for the clear for the extra neurotransmitter. So we can approaches for the different way to improve this functions also. It will be useful to approaches for the different disorders of the CNS. Okay, this is one of the endocannabinoid signaling. So this is we have different type of the endogenous cannabinoid receptors present in our brain. One is for the CB1 and also for the cannabinoid 1 receptor, CB2 receptors. So particularly for the CB1 receptor, they are modulating for the different type of the neurotransmitter present in the neuron. The cannabinoid and B receptor, they used to for the different functions. So maybe especially cannabinoid 1 function, it will be, correlated with for the anxiety and many things. So we can approaches for the this type of receptors, so we can develop for the some of the drugs. Okay. Yeah, microglial activation and also for the chronic inflammation. So, I think over activation of the microglial, they used to produces for the many, inflammatory factors. So they can induces for the inflammation to the neuron. So inflammation to the neuron, it will be lead for the neurodegeneration. So we have to control for the, microglial activity. So again, we can control for the inflammation of the neuron, so we can protect our brain functions and everything. So you can see the microglia are the brain resident immune cells. So in healthy conditions, they are monitor the environment. So when it will go for the overactivation of the microglia, so they are releasing for the different type of the inflammatory mediators. So the long, the chronic neuroinflammation, so it can be involved for the neuronal damage and everything. So it can lead for the different type of the neurodegenerative diseases. Okay. So for example, I gave you some cytokines. They can correlate it with the neuroinflammations, especially for the interleukin 1 beta. So they used to triggers for the inflammatory cascades like elevated. Normally they increases for the inflammatory different secondary messages and everything. So they can elevate for the AD and also for the brain injury. So TNF alpha. So this is one of the main pro-inflammatory cytokines. They can induce us for the neuroinflammations, and also they can trigger for the another cytokines. They can increase us for the inflammation. Again, for the interleukin 6, they can also link it with the glial activation and also for the blood-brain barrier disturbance. So when you look about for the inflammation, so we have different cytokines. We have many mediators are there. COX also there. Okay. Many mediators will be there. So when you look about for the cytokines, I think we have two different type of the cytokines. One is for the pro-inflammatory cytokines and also for the anti-inflammatory cytokines. Okay. Next. So here we can see the oxidative system again for the mitochondrial dysfunctions, how it will be correlated for the neurodegeneration. So the neurons have the high energy demands, so they needed more oxygen. You know, billion number of neurons will be there in the brain, so they needed for the high level of the oxygen demand. So easily it will be vulnerable for the oxidative damage. It can produce for the free radicals, ROS that can produce. So reactive oxygen species, so you can see for the superoxide and also for the hydrogen peroxide, so they are produced from the oxidative issues. So maybe they can vulnerable to the neuronal neurons and neuronal glial cells and everything. So when the ROS level it will be higher, so they can induce us for the oxidative damage, so oxidative stress, so it can be induces for the neurodegeneration. So normally they are linking for the different type of the neurodegenerative diseases like Alzheimer, Parkinson, so many issues we can be correlated with the oxidative stress. Okay. Okay. Again another way we can correlate it for the neuroinflammation, oxidative stress, again for the apoptosis. So these are, there is a lot of, the correlation between these things. So normally you can see the inflammation can increases for the oxidative stress. The another way oxidative stress can increases for the neuroinflammation. So again this oxidative stress it will be correlated for the apoptosis. What do you mean by apoptosis? Cell death, programmed cell death, okay. So maybe the oxidative stress or inflammatory reactions, it can be increases for the many caspases, many proteins of the related with, the apoptosis, it can be lead for the neuronal death, okay. So we have for the different approaches, you can see different type of the antioxidants. I gave you some examples. So N-acetylcysteine, so maybe it is related for the precursors of the glutamate, so it can control for the oxidative free radicals. So vitamin E, MitoQ, so this is one of the mitochondrial related antioxidant system. So these are, it can control for the ROS. So again we have for the COX-2 inhibitors. So basically the, the inflammatory drugs, it can be controlled for the, there is a lot of chances to control for the neuronal inflammations. Okay, sir. Okay. So these are the examples I gave you for the neuroprotective agents. Next. So this is also I gave you some examples for the anti-inflammatory strategies for the CNS diseases. So those patients they have for the, for example, rheumatoid arthritis or many things. So they used to take long time for the some anti-inflammatory drugs. So what the scientists they are telling, the patients they are taking long time this type of anti-inflammatory drugs for different therapy or whatever. So they used to have lesser chances for the Alzheimer issues and everything. So maybe it is correlated with the control the neuroinflammation. So this is one of the many studies is going on. Maybe non-selective COX inhibitors or selective COX inhibitors. Okay. Okay. So I already told about for the depression. I explained you everything. So basically the depression, so based on the monoamine, the lacking of the neurotransmitter. What are the neurotransmitters? Depression. So serotonin, norepinephrine. Okay. So basically we have for the many limitations will be there for the the approaches for the depression. So still there is a lot of development is going on to approaches for the specifically the serotonin selective activities and everything. Okay. The next. So this is for the some examples I gave you for the some depression therapy they are having for the different approaches to improve for the depression, mood depressions and everything. Next. So I gave some examples for the schizophrenia, so antipsychotic drugs. So you know two different classification of the antipsychotic drugs. One is for the typical, again for the atypical. I already told you the typical one, so they are approaching for the D2 receptor, they are blocking. So there is many limitations with the movement disorders, and also they are changing for the, prolactin activities and everything. So we are having the another second atypical drugs. So maybe they are approaching for the 5-HT1A receptor, 2A receptor like the serotonin activity. So we can avoid this type of the challenges. Okay, I already told you. So what is the issues with typical one? So we have to go for the new approaches. Atypical drugs, we have many drugs we have. So again for the epilepsy, so the traditional drugs they have for the lot of adverse effects. So they have developed for the different type of the drugs like levetiracetam. So they used to target for the synaptic vesicle protein 2A. So due to this one we can changes for the neurotransmitter. So we can control for the whatever the over excitation of the neurons. So and also we have for another approaches also including for the surgical option. So wherever the lesions or any damage in the neuron, so where it will be created for the seizures, so we can control it. So Parkinson disease. I already told you the Parkinson will be associated with not only for the dopamine, the other different symptoms are there. So maybe we can develop for the, we can try for the different drugs for the, whatever the symptoms it will be happening with the patients. So we can give for the some SSRI or cholinesterase inhibitor or melatonin. So we can improve for the other symptoms related to the whatever the Parkinson issues. So these are for some recent drugs. So one of the drugs for the monoclonal antibody. So that is they developed for the Alzheimer's disease. So again for the anti-tau therapy, so anti-inflammatory agents, and also for the neuroprotective agents. So we can follow for the different type of the lifestyles. So it will be different approaches for the Alzheimer and other neurodegenerative issues. So and also we can see for the some different type of the drug discovery tools we can use for the high throughput screening. So maybe the phenotyping screening it will be improved for the many number of the molecules we can try to find for the which one is active. Again for the in silico models we have, so we can using for the molecular docking and also for the QSAR studies. So easily we can find which molecule it can be fit for our targets. So and also we can use for the some different type of the organoids or same type of the models, 3D models and many things for like as a brain structure. So we can use for the different approaches of the drugs. So we can improve we can try to find which molecule it can be fit for the different type of the issues. So I give you some ideas. So we have for the, it will be allow for the some drug screening. So we can find the molecule, which molecule it will be active. Again for the toxicity testing and also for the disease modeling. So and also AA model, I think many, I think better, many things I think many speakers they talked about for the AA models. So machine learning model, we can use machine learning based on the AA model. So we can find out for the which molecule will be fit to that particular targets and everything.
Cleared.
I think, thank you so much.
Disconnected.
So this is not a deep break, I think. So I gave you that. Thank you so much. So any questions or anything you can. Okay.
Here.
Thank you. Sir. Neuro? Okay. Thank you so much.
Thank you, sir, for your wonderful words. To express our heartfelt appreciation, we would like to honor our resource person with a shawl and memento. I would like to invite Dr. M. Venkatesan sir to honor our resource person, Dr. Vasudevan Mani Kumarasamy sir. Please sir. Next, I would like to call Dr. Krishna Kumar sir, HOD, to honor our chairperson, Dr. M. Venkatesan sir. Thank you, sir.